Yeah, recording already. Okay. So, I opened your work. I think this should be. This is Mag or Bless. I can't remember who owns this. I think this is Mag. Okay, maybe going forward, if you just like the way I've taught you guys, yeah, yourself and Isiaku, you did your submission was nice because you zip you zip all of those folders together, and which is very good based on what we did. So I like that. So maybe what we're going to be doing next that I'm going to be showing you just that on your notebook, you'll be putting your names on the notebook apart from following the convention so that if, for example, we open this notebook now, we can see that oh, this is for um, Miss A, this one is for Miss B or something. I don't know. Blessing was having issue on the date on try to come up with the model. I really do not understand where our issue is coming from, but all the same, the two of you did well, so you were able to make the model. This is where we stopped last week from my own notebook, if I'm not mistaken, because this is the stuff here, right? Can you still see my screen?
Yes, I can see your screen.
Uh-huh. So this is what we are doing. So for the first part of this correction, we did import the data. So after which we saw that this is the data set, which we call a flood data. Then we want to try to do the pre-processing. So pre-processing simply means that you look at the characteristics of that data and see if there are irregularities and try to make it right. So when you're trying to do that thing, trying to correct some errors, which can be anything in the data, what you are trying to do is pre-processing, and that is what we target. So in the pre-processing step, you can do .shape.info and describe just for you to understand where errors might lies in the data set. So if you find any, check the missing value, check the duplicate, check outlier. So many things that you can do when you're doing the processing, whatever. So when you find any error on none of those things you are checking, so the right thing to do is to correct them. So process of identifying errors in our data set, correcting that error is what we call pre-processing. You're trying to pre-process the data set in a way that it can be fully ready before you can push it into a model. That is what it simply means. So your pre-processing step can vary depending on what individual is seeing in the data set. Do you understand me now? But it is important for you to ensure that at least you're able to identify what will make the model behave better on the data. So that when you find it, if there are errors, you correct. If there are no errors, you leave it. So while what we are trying to do that, we were able to see that one of the observation that we saw is on the describe. We can see that oh, the mean of this data and the standard deviation are not really looking like it's approaching normal. Not by normal, I mean, no, I'm expected to see that maybe the mean should be 0, standard deviation should be 1. You don't have it at default. So if a data set is given to you and it's not showing that, it's not like there's a problem, but it just guide you to know if you want to go into the process of transforming either numerical, either categorical encoding, you understand that, oh, I think this is the best method for me to use when I'm dealing with my numerical data or categorical data, as the case may be. So this describe will allow you to have idea of the type of transformation you will use on the numerical data. So, for example, here we see that the mean and the standard deviation are not really 0 and 1, and that is what you should see, basically. So this is what should guide you. Apart from that, you can also check the distance between one point and the other, which we call the minimum maximum, to see is there any variation, is it too wide or too close, depending on which one is more pronounced. If it is the boundary value that is having problem, which means minimum and maximum. So by the time you are doing your transformation, you already know that you're going to use min, max, scalar. if the problem is around mean and standard deviation, you already know you're going to be using standard scalar. But if you're not too sure or you want to be generalizing, you can normalize. So normalization will take care of either a standard scalar or either is minimax, depending. And in fact, in some cases, you can even use the three. You can standardize, you can minimax, and you can still normalize. Nobody will penalize you. In fact, in practice, like when you are running your exercise, like you are training yourself on learning most of these things, you can begin to do, first of all, standardize, build the model, look at what the model looks like, look at the performance of the model, go again, that same data set, instead of standardizing, use minimax, see the effect, go again on the same data set, do normalize, see the effect. Again, do the theory. Do you understand what I'm saying? Like you are just practicing, because it's in you doing this, you will be able to see different behaviors of what the accuracy of the model is looking like, and it will inform you to understand. At times, there might be improvement when you use the two. Let's assume you use standard scalar and also minimax. There might be improvement in the model compared to when you only standardize. And at the same time, there might not be any significant improvement when you use standard scalar and mean and minimax. So it depends. And again, even when you use the three, like you standardize, you minimax, and you also normalize, it can impact the performance of the model. And at the same time, it might not impact it, but it's not an issue. It is you that you are trying to explore different possibilities. And if you try it as many times as you would want to do it, you can now say, okay, I think on the average, this one always work for, like it perform better. Maybe it is standard scale that perform better over the general practice that you'll have done. Maybe it is minimax that works better. Maybe it is normalized that works better. Do you understand? You can take a conclusion, but there is no go-to method. Of course, this describe will help you to know, but on the long run, in practice, in real scenarios, anything can work. Do you understand? You just need to understand when to use what and how to use what. So that is just the concept here. Hope you can still hear me.
Yes, I can hear you.
Uh-huh. So you now cannot see the screen. No? So is this Zaku still in class?
Yes,
Zaku.
he's
I'm in the
here.
class. I'm in the
Okay.
class.
Okay, good. So we pick a conclusion from this description to see what is the behavior. When we also check for the missing, but we also apart from min max, mean standard deviation that we're able to deduce here, there's another huge problem. There is about 16,000 missing value. That's also help us to say, hey, this is going to be a great problem. If the total value I have in my data set is around 20,000, and I've been told here that 16,000 of it is missing, then that's another concept. Okay, I know that when I have missing values in my data set, what is normal for me to do is to remove the missing value. Normally, like drop any. That is what we should do. But the logic is that, if 16,000 is missing and I have 20,000 in this data, normally if I remove 16 from 20, I only have 4,000 remaining. Then does that mean that if I now use this 4,000 remaining data set to build my model, will my model perform better? The answer is no. Why? Is because larger volume of what should have impacted the behavior of the model, you have removed it because it contains missing value. Therefore, another logic or strategy we came about last week is to say, you know what, when the percentage of the missing value is like more higher, like it's taking about 50% of the entire data, the approach is not to go and drop it. That means to remove it. It's not always the best approach. So the right approach is to see that, I can't remove all of this. Okay, how then do I go ahead to treat this missing value, which is where our first point of call came up last week. So that, okay, I can't remove it, go and drop. So fine, if some people that did not know, this strategy is, you're not likely to find this kind of techniques in textbooks or anywhere. These are, what do you call, these are like professional way of handling issue, because these are realities that you will encounter in real life. In fact, in real situation, you are likely to have more values that are missing from the entire data set you have. So you're trying to build a model that will generalize the behavior of what is happening within that data data concept. The next thing is that if you go and remove it, which is normal thing that somebody will have done, that somebody that went to read it from the textbook or something, that's what you're going to do, just remove it. But if you remove it, you will build a model truly. Your model, you will test the accuracy, is going to be fine. In fact, it's going to be behaving very fine with the remaining data set. But what about those features that you have removed that the model should have learned from, but you have removed it? So if you are bringing a new data set that now has one or two behavior from the one you have removed, your model will not perform better because it did not learn it. Do you understand? You have removed those concepts from the data set and you have built a model that does not learn those concepts. If you are now using that same model to be making predictions on generalizing every behavior, then by the time you encounter the one that you have removed, the model will not perform better. So simply, it is not always the case of just drop, 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 drop. And that was the concept we tried to leverage last week. And that's okay. Where do we have this problem? We know that the problem arises from the target column, which is the flood. Okay, if this is where I have the problem, because at times you can have the problem in more than one columns. I want to be thinking in that regard. As you have it under the flood, maybe you also have it somewhere around all other columns that we have. So you have to understand this column that is having this missing value, what impact did it make with the generality of the data. Let's say, for example, our missing value is on SI. Let's say, for example, the question is, what does SI do with this data? When we look at it, SI is just like indexing. I don't know if you're getting me. So even if I go ahead to remove SI from my data, I will not have any problem because SI is just simple index. Do you understand? An index is not a characteristics I want my model to learn from. So if I have such, let's assume you have 16,000 a year now, and you also have 16,000 a year. So this SI is not relevant. That column is not relevant to what I want to achieve in the end. So therefore, if I remove it, I'm not going to be penalizing anything. But it's going to be dangerous if I go and do that for flood. Do you understand? Because it is possible that you have such scenarios in more than one column. It's for you to understand, is this column, does it have any significant impact towards what I want to achieve? If the column is yes, if the answer is yes, rather, then removing it might not be the right option. So the right option is for you to see how to devise a means to what? To correct that missing value without not removing anything. And that is one of the strategies what we embark upon last week. Any question? Any
Not
question?
from me.
Good. So
No.
we check duplicates, we see that there's no duplicate in the value, so we are good. The only problem is missing value, and it's very much. So based on that concept, you now say, okay, what can we do? Then we try to select that I taught you. This is like renaming, maybe because the way they name, maybe there are some column that you don't like the way they name it. You can change it to something you wanted. So this is the code to do it for any column, depending on which column you think you don't like. Let's say you want to rewrite this X coordinate or Y coordinate. Just do this to what you want, and it's going to implement that whatever. So we have changed the flood question mark to flood now. At least we know that if we call upon it anytime in the course of this building, we are going to be certain that we are doing the right thing. So as I've said, we've seen that the SI column does not make any impact. It's just index. It's just like I'm having double index. So because of that, if I try to remove it, nobody will penalize me. So which is even the right thing to do. I cannot have one index here and I will have another index here. It doesn't make sense. So two index does not make any sense. So if I decide to remove one, I'm okay. And we decide to remove the SI. So when we did that, this is the column that we use to the code that we use to remove the SI since we don't need it. So this is now like my original data, the way it should be. Nothing has happened. Now my focal point will now be that column that has higher missing values more than what should be normal. Then we focus on it. And because it's the target, so it is as important as any column you can think of. So I cannot say I should drop because that is what I'm trying to predict. And what I'm trying to predict is having more missing value. So therefore, it's an important column that I need to really work on. So this is trying to just play around it. So as I've said, one of the method we know is to
I
do.
want to ask a question.
All right, go ahead.
That
Yeah.
place we removed SI. What if we want to leave the SI and remove that other indexing? How do we do it?
No, you cannot remove under. This one is default.
Okay.
This is like the, how do we put this? This is what was created maybe when they're trying to save the data. This one is the original index that your data will have. There's no data you will load that will not have a default index. You understand? You understand? I know it's
Okay.
pandas. It's a pandas data frame. It's like Excel. There will be row and column. This is the row number. Every Excel sheet has row number. Yes or no? Yes.
Yes.
So there is no way you can remove the row number from because this is what you use to trace every element in the data. So if you remove it, which is not even possible anyway, if you remove it, how do you want to trace the row? Do you understand? So you
Yes.
can't. So this is the one that, because this one now has a column header, it's easier for me to remove because just call the column name. Okay, which column you want to call this one? Does it not have any column? No. Are you getting the
No.
idea? So
Yes.
that's it.
Yes.
So you can't remove that. It will always be there by default. So this is the convention. This is the normal way we learn how to remove. But if you go and do that on this data, we have just keyed the data because automatically, if you look at it, there are three values that are available: 0, 1, and none. When we do the value count, 1 has 4,000, 0. So it means if you go and do drop A, this is the information you're going to be using to build your model: 4,000 plus data as to 20,000. You know that model will not learn jack. It's not going to learn anything from the data. Rather, it's just going to learn rubbish of this 4,000 that we have loaded. And that is what is going to be using to make general prediction, which will not be correct. So that is one of the advantage of following the approach. So the next thing is we now use the column that we have known that has a problem to split the data, so that from the concept of the column I know, I can split my data and try to see what is possible. Okay, so we try to see using the concept of what we have learned. The column of interest is the flood. So let me use it to split my data. So since I know that the flood column has three possible categories, it has the land, it has the one, and it has the zero. So I can separate into two. Take all the nans to be one data, and every other one, that means 0 and 1, which is not going to be land. So it's like we are trying to divide these data into two, based on the column that we have known that has a problem. Now, the one that has the problem, which is the land value, and the one that does not have the problem, which in this case is going to be 0 and 1. Do you understand? So, which make that division. So, what we are trying to do here is to show you, I was trying to explain to you what it will look like. And at the end of the day, this is what generalized the force splitting. This is flood data with none. And for me to get it, I call on the data frame, which is what we call flood data. Then data name again, then the column that I have interest. Dot is NA. Is NA means that go and pick all the ones that has none. And that is the graph. I've explained this one to you last week. So immediately you do this command, the data set will be splitted based on the one that has NA, because that's the command we have inputted here. Is NA. Grab inside the data frame only the columns or only the rows that has NA. And that's what we're going to do for you. So by the time we can see the flood column is the interest. That's why we're indicating the flood. It has listed everything in this column now. In this data set is only land value. And if you look at it, it will contain total number of land that we said it was missing, 16,051. So 1651, if you go and look at the NaN value based on the info, whatever, you see 1650. So automatically we have been able to grab all the total NaN. Do you understand? In the data, which is very good. That's the first splitting. So the next splitting will now be the 4,000, which means the combination of the 1 and the 0. So if I use this equation or this code to grab when it was NA, for me to know that when it is not NA, is that I first of all say, okay, greater than 0 or equal to 0 equals to 1. So if I want to put the two together, because I need to bring them together, I can use greater than or equals to 0. That means from 0 above. Then it's going to grab everything that is 0 and everything that is 1. And that will be another data set I wanted. So I was able to take it one by one with you. We did for 1, you see, for 1, the flood will only be 1. We also did for 0. You see that the column is all 0, but you can combine these two. If this is what you understand, the next thing you're going to do from here is to concatenate this guy and this guy together, which is like you are following through a long process. I can write the same just single command and to grab both 0 and 1 for me. So how do we do it? So we extend it to this is what you can do. Combination of greater than or equals to, and you grab all zeros and all 1. Why this one is good is that if the values is more than 0 and 1, maybe the values that are positive in the equation are 0, 1, 2, 3, 4, 5, 6. Let's say, for example, do you want to be doing it one after the other? Do 1, do 0, do 1, do 2. That's like wasting of time. But I can combine and say greater than or equal to 0. It's going to start from 0 up to whatever it is that it has. Do you understand? That's what this one will do for you. Do you get the logic now? That's what this one will do for you. Okay? Hello?
Yes.
Yes.
That's about that line. So automatically, we've been able to achieve the second separation, which means this is now a data that the flood does not have NA. And truly, that is what it is. If you look at the flood now, it's comprised of 1 and 0 because of this equation. Okay? So if you want to know 4493, this is total number of rows in the data set that has no missing value. If you want to go and confirm as well, go to where you did value count for the flood. When you did the value count for the flood, this is it. If you add these two together, it should give you 4493, and that is it. So you automatically, you've been able to, because you need to check all of this so that you are not missing anything out. So we know that I know that that's what it's going to be, because the two split I have done allows that to happen. So I've now been able to get the two data. So what do we now do with this data set? I was telling you last week that what you now need to do is that you use the one, just like the law of economics. Use what you have to get what you want. You have learned how to build model. This is now where the skills is coming. This is what will differentiate you from every other person. Imagine this is the project that was given to you, and you have like 10 of you on this project. You have learned another skills to do it better, because I've learned model. Okay, model is used to predict. Okay, if I have a data set that has no missing value, that's a good data set for me to build a model. I can build a model on that data set, and I'll still use that same model to predict, because that's the goal. The goal is build a model, supply data set to that model, and let that model predict what you're looking for. So the concept is that, oh, okay, if I have the one that has no missing value, let me build model with that one. And when I build model with that data, and then the one that has the missing value now will now be the test set. Like you have the training set, you have the test set. The training set is the one that has no missing value, which you are going to be using to build the model. After you are done building the model, then the next thing is to now put the test set, which is the one that has missing value, for it to predict that missing. That missing in this case is the flood. So that is the concept that I'm going to come to, because you know how to build model, and that's where we stopped last week. Any question? Any
No
question?
question.
Good. So let's
No
begin.
question.
So this is like a summary of where we are from last week. And let's now remind you, so all those things you have now learned on building your model is now what you're going to apply. So taking, for example, that your linear data set now therefore is the one without missing value. So that's where we are starting from. So I give assignment and I check all of what you have done. You did well and it's okay. So let's just continue on that basis. So today, today we will start on our red notes. So building the model that we will use, we will be using to predict the NAN. So being the 15th of June 2024. So okay, voila. So it's too small. Let me make it there. Yeah, so we'll go now. So based on what we have done, which all of you have attempted, is okay. So I really don't know where Blessing is having issue, but this class should. So I know that we now have two different data sets. Let's call those data sets. Maybe I will need to run this. Let me see if it call it upon fine. Even I might need to run it again. Let me just quickly run it so that you don't. Uh, okay, I think it should run. Let me just call the data set without. If you know what times have to start without. So it's saying doesn't have to run this again. A minute. Just want to run the. Let's run it again so that we will be on the same page. On our OS, this, take it back, load our data set, we did the dot shape, the info, the describe, this, we name, it's trying to see the column's name. Here we drop the SI. Looking at it again, let me do dot add here. It doesn't load the entire dot add here. Show me I've removed that. Look at the float column, check, look at the counts in the columns that are of interest. This is the missing value. So just to look at the unique data, 33 entries, this one will guide you on. Maybe you should remove flood none, yeah. So we selected now. At this point we are selecting. Let me put a name here. The column header. We know that we are selecting the data frame with none, so that when you are reading it, you don't look at. You can quickly grab it. Okay, what we did there was selecting. Okay, so I did the selection. Voila, we selected. From that, we are looking at what we have. Is explaining each of those ones. We grab for one. If not save it into anywhere, we grab for 0. Then to make it very easy, data without none. 1, 2, 3, 4, 5, 6. So I also grab this is for. So the two data set has been grabbed. Therefore, I call on without none. So this is it now. So I just do false true. So this is the without none. So this is like a complete data set now. And when we have a complete data set, what are the steps do we follow? In this case, we want to believe that there will be no missing value in this data. We want to believe there will not be duplicates, at least on the basis. So if I want to check it, no problem. But if I don't check, I already know that this data set is like a complete data set without no irregularities. And once I get that, I can go ahead and build my model with this data by doing the feature selection, column, whatever that you need that we always follow. Do you get it now? So, but you can play around to see maybe there's still missing value, but I know there should not be. So this data I have now, if I do this data thereof dot is none, this is just by the way dot sum, just to be sure that you see no missing value in the data set I've selected. So it's good. Let me see if they are duplicate as well. These are just things that you can check. But based on what you have done, you expect not to have anything. But in case you have, maybe there was a mistake where you're trying to, that's why you're checking this. So we are very confident that what we have selected has no issue. But let's see if it has duplicated. So let's see if it has. No. So good. No missing value, no duplicate value. This is like a complete data. So what is the step? The next thing is we select features, right? Select your X, your Y, remember those things. So, and that will be the next thing. But there are things we always do normally that you can select the numerical column, categorical column, and begin to do the transformation. Do you remember? Do you
Yes.
remember? Okay, so let's go ahead and select the numerical thing so that you can see that selection of the numerical column is already okay. They also pick out the categorical column and see that you can do the separation. So let's select columns of interest. So the something will be selecting numerical columns. So if you want to select numerical columns, so this can be num data none without none. So the data set name is this. So you want to select. So do you know the columns of the numerical at a glance, or you want us to list it? Ellie, are you there?
We can list it.
So I told you, good. But for list, I told you that the shortest way is for you to know the columns so that you can copy is to say these dot columns. Now this will give you all the columns in the, you remember? This will give you all
Yes.
the columns so that you don't need to go and be going up and be checking which one. Do you understand? So this is it. So I can just copy what I need. Are we together?
Yes.
So I assume now we can pick all the columns that we need. So into let's copy. So this is only numerical is the station names, right? Station names.
Yes.
Yes.
So
That's the only
everything
categorical.
I saw this thing from this place will be numerical, right? Control C,
Yes.
Control V. So later I do this, I have selected some are not okay. So I'm just complete it. This which other one? Yeah, everything is fine. All right, good. This is now. So if I want this, I have passed the data set. Don't forget. So what automatically is going to give me only the selection of the columns with numerical alone. Do you get what I did now? Do you get what
Yes.
I did now? So if I do this now, num data, do you see now? I've been able to select it. You see as fast as it is. Okay. So for the category,
Yes.
for the categorical, so num that's the cat data without none, right? So the same thing will follow. My data set name is still this. I put it here. Then it's only just one. It's just the station names. Are we correct? Station names, right?
Yes. Yes. It's only station
Yes.
names.
Station name. So when I pick this, Control C, Control V, dot end. Okay, this is now. So we've selected it. So I've selected the numerical, I've selected the categorical, and that's what you will do. Even if the categorical is more than, this is what you need to do. At least the separation is well done now. So when you have, after you have separated it, the next thing is to transform. So we're going to transform this data, transform numerical, then transform the categorical. So for transformation, you can stick to one. Let's assume that based on what we had in the descriptive information, standard scalar is what we're going to be adopting. Are we good? You can use anyone based on the information. Now I've explained it, but let's say for the purpose of generality, we want to use standard scalar on this data. Are we good?
Yes, we
Are we,
are good.
okay, let's standardize it. So if you want to standardize, you call on your, so the next thing is follow this step that we are taking. Please note, because still going to repeat is standardizing the numerical columns, or no matter whatever. It's just like Eddie. So this. So I already know mine. So we should, from what? Can you tell us the library? Who can import it from? Oya Mag, tell us the library. I believe that library should be ringing in your head now. Oya, tell us from. Don't copy you. From SKLN.
From SKLN.
Dot. Bam. Somebody's checking somewhere. They begin to gaggle. I know Isiaku is on Google like this.
She's still rocking. She's still checking. Wait.
I know Isiaku is already checking. Are you telling me Isiaku?
Honestly, I'm not checking. I think it's pre-processing, but I'm not checking.
Okay, good. If you don't check, it's good. You actually dot pre-processing. That's good. Okay, dot pre-processing. Look at what we are doing. I told you, we are pre-processing data. So anything we are bringing on, standard scalar is a pre-processing step. So it is pre-processing. Okay, at the time you keep doing it to understand it. It's pre-processing. From SQL the pre-processing. Import what? Mag.
Standard scalar.
How do we write it? Standard.
Capital S.
God bless you. I purposely want to make mistake. Maybe you don't know what I'm doing. Okay. Standard scalar. That's good. So this is it, right? And then when I run this, we should be fine. If you are not fine, to tell us, so we are good, right? So the next thing is we have to initialize this, right? So let's initialize the standard scalar. You can call it any name, initialization. So for me to initialize, let's just call it scalar for it to be easier for us. Just call this copy. I don't want to be right so that I don't make mistake. Then initializing them must be. So if you want to see it, maybe it has been initialized. Just do this. So initializing, it has give you that the processing module that I want to use. So your module will have dot fit and transform, right? Those are the two things you do. Do we still remember?
Yes.
All right, good. So you can do that, and then if we should pass the data frame on it, yes. If you don't want to, remember that we always convert it to array. If you want to convert to array, you can. So it still does not matter. Do you get the idea? Do you remember? Do you remember?
Yes. Yes.
And so let's maintain all uniformity. So the data set now, let's convert it to array. You remember the values that we will do. Then you pass it. Are you getting it? Hope you have not forgotten.
Yes. No.
Okay. So before we move ahead, so that we don't jump the step. Let's do another thing here and take the target. Okay. We've selected numerical. We selected categorical. So let's also select the target from the data, right?
Yes.
Yes.
You already know target data. Target data. Okay, let's just pick it like that. So this target data will be my data name, data set name, then column target. Column target in this case is flood, right? So if I should run this, Control C, Control V. Okay, right? Any
Yes.
question? So that the essence of why I did this is we can be on the same page. Do you get the idea? Are we still together?
Yes.
So for us to transform, let's now transform the numerical. We transform the numerical, we encode the categorical, the target. Can try to leave it the way it is. Hope you are not having any issue around that.
No, not at all.
No, at all.
Yeah, let's go ahead. So for us to standardize, it's going to be scalar dot
Fit.
what are we passing? What am I going to pass inside the dot fit?
Dot fit.
What am I passing inside the dot fit?
Num data.
Scalar.
Is that?
No, the name of the data.
What's the name of the data? That's what I'm asking. What's the name of the data?
The numerical one.
Which is what?
I think it's okay.
This is
Num data WO
the
num.
WNAN, right? Right?
Yes.
Yes.
So if I put it here and I run this, okay, and I do fit already, then I have to do what? Transform. Is that clear? Is that clear?
Yes. Yes.
So num, but that transform now need to be saved inside somewhere, so that will be the transform data. Okay, num data. Let's just call num data. Will now be scalar dot transform of this now. Okay, right?
Yes.
Then num data. So this is the transform data. What's it saying? Oh, okay, yeah, sorry. Can you tell me why?
Because of the head that you put there.
So you remember, because it's now an array, right? So okay, have you seen it?
Yes.
So our num data is already done, right?
Yes.
So if you want to know, to see if you have actually achieved it, I can run a code for to see what is the mean, what's the mean, what's the variance. No, this is the num data is the new data. Num data dot mean. Let me see. 0, right? 0, right? You know, this is raised to power minus 15.
Yes. Yes.
Like 0.0000,
0
which is
points.
good. So and then I can do num data dot std, and I can round everything up to see, run this up in this and in this. Let's see, round up. Okay, let this be individual like this. Okay, round up this, round open and close. You see, can you see it now? The mean is 0,
Yes.
the standard deviation is 1. You see now that is what standard scalar we do for you. So already now, the mean has been compressed to not to take any value that we saw in the description, rather than 0 now, and the standard deviation is 1, which is the general rule. Do you get it now?
Yes.
Exactly.
Yes.
Good. So
Yes.
I just show you this for you to know. You can always run it. It's not like a step, but for you to know that whenever you pass the standard scalar on your whatever, the essence is to take it to 0 and 1. Okay, so which is good. But if you do it on, if it is minimax you did, it will not be 0 and 1. No, minimax, it does not. Minimax is not speaking about mean and standard deviation. Okay, it's talking about extreme values. If you do normalization, you might have it, but it might not really 0 and 1, but just normalization. You have to understand what works, okay, for each of those things. Are we good?
Yes,
Are
we
we
are
good?
good.
So the next thing is we have done transforming the what's it called? The numerical. So you need to transform the categorical now, of course, because we need it.
Yes.
So categorical now, transforming the categorical. So let me make it a header. Also encoding the categorical data. Abi, from what we have. So the categorical
Yes.
here is just 1, and we are fortunate, right? It's too small. We are fortunate that it's just 1. It's no problem. It's just a single column. So, and then if you look at the columns that you have here, we've seen it that there are 33 of these. So the next thing is, of course, each of them should be unique value in their respective way. So, what are the categorical steps in terms of how do we encode categorical variables? Can you tell me different ways in which you can encode them? How many do we have, or how many do you know? Based on what
I
we have been.
remember 4.
All right, number one.
Label,
Yeah,
ordinal,
yeah.
one hot, and um, ah, label, ordinal, one hot. He remain one. Oh.
Yes, we are listening to you, dummy.
Yeah, hey, dummy.
Dummy. Okay. So, which one should you use there?
One hot.
Good. Why do you choose one not?
Because we don't want it to have different, because it's not ordered, number one, like in the case of ordinal.
Mm-hmm.
And then we don't want it to have plenty columns, like label.
No, you are missing it. Plenty column is what one not will give you now. One not will give you plenty columns. One not will make your data to be big. Label will just give you a single.
Okay, just give you one. Yes, label will give you just one.
Column. The only
Yes.
thing is that you're going to be using number to represent all the
Yes.
unique elements in that column. But one
Yes.
not, it's going to be picking them one after the other and be doing 0 and 1 for them. So if there are 50, here we have 33 columns. So it means that by the time we do the one not, each of them will take their position. 0, 1 up to 33. So it's going to be blown, but there's no problem. Which is even the best thing to do here, because number one, truly they are not ordered. It's just like name of states. No,
Yes.
no, we cannot say Lagos is the best to Abuja. No, there's no yardstick as that. You understand? We're not even interested.
Yes.
Let Gombe be the best state. What concerns us? Do you understand the idea? So we're not interested in how these things come by. Rather, they exist. You just want to make reference to them. So in so doing, you use one not encoding. Okay. So
Yes.
yeah, tell us the library for one not encoding. Eziaku, not you this time. Eziaku. Eziaku, don't check.
I'm not check. I'm not even with my laptop here.
Oh, okay. Yeah.
From SKLN, Abi.
I don't know. They're teaching us.
I am saying from SKLN.
Okay, from SKLN. Yes, we have written it. We have to even put dots in case you forgot the dot.
Dot.
Yeah,
One
we have
whole
put dot
import.
from what? S dot what?
I can't
We are
remember.
lost. We lost you.
I think it should also have preprocessing, Abi.
Yes, now she has jumped that step and she just said dot one. I was afraid when she said dot. I said, where are we like this?
Import one hot encoder.
So that's it. Everything, whether you are doing scalar, anything on the transform is the dot processing you use. Okay, transformation. Either it's numerical or categorical, just dot processing. Then call the type of whatever you want to use. Okay. So we also initialize this one a bit. Let's call it one not. Can call it any name. So initializing it. Um, okay, any question there? Hello.
Oh,
Is there any question?
can you hear me?
Yes.
Yeah, I can hear you. I'm asking if there's any question. I'm asking Eziaku. Eziaku.
No question. No question.
Okay. So we are good. We are good. One not encoding. Check.
Yes.
No, let's say that. No, she was not that. She's the master of this one. She's not that's leading us. So have we initialized this very well?
No.
Why? What's missing? Take your time.
I think we are supposed to do like maybe we'll call the name of the data equal to I think it's one hot dot transform. Then we'll say sparse. I think sparse
No,
equal
that,
to
I want you
something.
to take your look at it. What we have done now is initializing. You know that's what we did for scalar as well, right? So have you initialized it correctly or not? That's what I'm asking. We are at this point. Have
Yes.
we initialized it correctly?
Yes.
Yes or no?
Yes.
Okay, so let's go ahead. All right. So after initialize, you do fit and you do transform. Hope you have not forgotten.
No.
All right. So let's see. So all of us will see together. So initializing it is one out dot fit. Then you are passing the scalar, right? I mean the categorical, which is this
Yes.
thing. Control C, I paste. Then if I run this, what did you see?
Error.
So what was the error?
Oh, we did not do dot values, Abi.
Me, I don't know.
Nothing is showing. No.
Maybe it's your network. Oh. Something should show.
I'm seeing where you initialize.
Dot values.
Wait, Jacob. What's her name? Um,
Mag.
Mark, can you still see the screen?
I'm seeing where you initialized.
We have passed that stage. We've now
Oh
we fitted, yes, we fitted it now. So I want to agree that you can see a screen that has error.
no. Let me leave and join again.
Okay, let's wait for you. We have do that and wait for you. Isiaku, sorry, let's wait for her.
Oh, no problem.
I'm here.
Okay, can you see? Can you see the
Are
error?
you still sharing?
Yeah, I'm still sharing. Isiaku, can you still see that I'm still sharing?
Yes,
Yeah, we're still sharing. Confirm if you can see it.
I can't see it too.
Ah,
I'm seeing the names.
no, you should see the notebook we are using. What you should see is encoding the categorical data set and you see some jargons after it, then an error. Your network. Which
I
network are you
think it's
using?
my settings. I'll sort it out.
But we
Just
have to go.
continue. I will follow.
Okay, you follow. How do you want to follow when you are not eh? Hello.
No, I'm trying to check if it's my settings.
You
So
shouldn't be
because
setting. Do
I
you
don't
do
know.
any setting in the okay? What I'm saying is that this is what we have. We've tried to do one not encoding based on our steps to follow, but we had an error. So I'm not asking. No, when I initialize the what's that guy? When I initialized the one not encode, I asked you right that the have you initialized correctly, and we said yes. So we now try to do the fit. Now we had an error. So the question now is what went wrong? Hello.
Hi.
So what went wrong? We had an error. So what went wrong?
Is it not this one that we are supposed to put the value to change it to?
No, don't forget that it's still categorical we are doing.
Okay.
Yeah, it's categorical. It's not entirely numerical, right? So we have done the right, we've converted numerical, yes, but we are now in categorical. So we did our one not coding, we passed the fit, it throws an error and it's telling you that expected two-dimensional array but got one. So I'm asking, what is the problem?
Is it here we are supposed to put the seed number and is it
Split
something?
number, split number how?
There's a place you're supposed to put the 20. Then in the other, there is one long code you usually write here.
Okay. Now put I want you to talk like a data scientist. One long code, who's 20? Yeah, explain yourself.
You put the number of, is it the number of I've forgotten. If I was with my system, I would have remembered.
Why don't you have your system with you?
Let me check if it will on the person. I like after class, I will then practice with it.
Practice, okay, it's good. It's good.
This I'm in that row. No light. Let me check
Oh,
if
oh, you are back to your space.
yes. Mag.
Okay.
Yes, I can see it now.
Okay, good. Who called Mag? Is Blessing in class?
No, I was the one that called Mag.
No,
I
it's
Oh,
wanted to.
okay.
Emeka.
Okay, okay. So let's move ahead. Now, if you look at what this one is saying, he said it's expecting two-dimensional array, but it got one instead. That's the error. So at this point, we might need to redefine this. Remember when you are defining one not encode, I told you sparse output be false, does set output to be transformed equal to pandas. So that is the only thing we did not add there. So let's add it and see if it's still going to get it transformed. Okay? Are you getting me? This is what we did not add. Here, sparse output be false. Let's see. Then dot set output as pandas. Dot set output um, transform equals to pandas. Pandas. So let's redefine this. So let's reload this. Yeah. Let's redefine this. Yeah.
Please, what is the meaning of that sparse output?
That which
Can
one? Sparse out.
you?
Sparse output.
Yes.
So what's the meaning of sparse in the first instance?
To spread.
Okay. So what he's saying is that let's assume that in the data set there's some uneven distribution of the points, like maybe there are 10 different points. So there is information on number one. The next position that you have element is number 5. After number 5, maybe you have at number 6. It jumps again, go to number 9. They are those elements, those data points are sparse. You understand? They are not dense. So he's saying that in case he's doing it and he encounters such, you should just ignore it. That's what you are saying. Do you understand? In case, in terms of position of the data set. Is that okay?
Okay.
So that's what he's saying. So we say that whenever you see it, ignore. Okay?
Okay.
Uh, that's the meaning of false. Then I told you to set the output as pandas. Yes, that means it should return. This one is telling you that return it after you are done doing the one not encoding. Return the answer in form of a data frame. That's what this one says. Set the output to be a pandas, like set it out as this kind of thing. Okay.
Okay, because is in the this thing is in array.
Is that what? And look at what this one does. When we do the scalar, what was the final result? An array, right? So imagine that when we do the one not encoding, it's going to give you also an array. And I said, don't give me an array. Return it in form of a data frame. That's what this one is saying. You get the
But
idea now?
why didn't you also tell num data to return it as pandas?
No, you can convert. This one is numerical. There are two different scalar you're using. This one is standard scalar. Standard scalar does not allow this information. So each of them has what they take in. Okay.
Okay.
I'm just setting it to see where the error is coming from, right? So even if you do not put this, don't forget that we did not put it in the first place. It's not as if, and you did not add this, it's not as if your something will not, it will transform. There's no problem. You get the idea? We're just trying to see to be sure that in case, because the data is so big, you might not even know where error comes from. By the time you set these conditions, it's just making you to be sure that anything is going to be giving as an output. You are confident that it is going to be a good thing. That's just the difference. Do you understand that now?
Yes, very.
Yeah. Yeah, that's just what it is. So where we are now is we've passed this information and it's telling us that I've fitted the data. It's complaining about it's expecting two different dimensions, two different array, but it got one. So what it's saying is that this column, let me do
Hello,
fit
Ola.
transform. Yeah, I'm with you. Fit transform. I'm with you.
I
Just go
think
ahead.
I think the problem is when we defined the categorical. I experienced this thing several times too, where we define the categorical.
Okay.
And what I use usually is I set the categorical to like the name of the column first.
Yeah, that's what we did now. Look at the categorical. Let's take it again. Where did we do?
Please, can you show where we define the categorical?
This is the categorical here. This is the categorical. Right? Yep. This is categorical. Is that correct, Ezeaku? This is the numerical. And this is
Data.
categorical. Yes or no?
Yes.
So yeah, Mag, let's hear you.
Is numerical. I'm not seeing categorical here.
Maybe this is your network. This is categorical. Can you see where I highlighted?
As data and no NaN dot head.
Do you see what I highlighted?
Oh, hey God, I beg you.
Your
I'm
network.
not seeing
Which
it.
network are you using?
It's Wi-Fi,
Well,
and it's a strong Wi-Fi.
which you are ISP, internet service provider. Who are the internet service provider?
Who is what?
The ISP, internet service provider.
Is that a Wi-Fi?
And Wi-Fi, we have something now. Wi-Fi we
Me, I
just
don't know.
she says it's Wi-Fi. I know it's Wi-Fi. Wi-Fi we have the service provider, those people that are network people. It might be MTN, might be Airtel.
I don't know the network.
Okay. It might be Swift, it might be all those names. Oh yeah, can you still see the screen now? Hello.
No. The screen is showing, but the categorical.
In fact, it's still highlighted. Your network is kind of dragging. Your network is kind of dragging. You should be able to see it. So yeah, tell us what you say you did. Let's hear you. Mag. Eziaku, are you still there? Because I can't hear Mark again. No. Eziaku.
Here. I'm here.
Okay. I can't hear Mark again.
Mag is still here.
Mark,
And do you know what?
I'm with you. I don't know what. Tell me what.
Okay, I did it exactly like you. Shebi is no longer giving error.
No, there's still error. So, but she's saying something. Mag,
Can you hear me?
yeah, we can hear you. Go ahead.
Okay. So what I did when I was experiencing that issue in this categorical here, the first line, I did categorical column equal to in brackets station names like you did it.
Yeah,
Before this, your first line, there's a line that I used.
yeah, tell us what you did.
Like,
No problem. Just continue.
no,
Yeah, now.
like I did categorical column equal to square brackets, station names, right? Then the next line, I now did categorical data equal to the way you did this one now, exactly how your flood whatever data. Then
Yeah.
in bracket instead, I did not put station names now. I now put the categorical column that I used
Yeah, they have
to.
different. Yeah.
That's what I did, and
Yeah.
its error stopped.
Yes, now it will stop. So, do you know what you did there? Do you
You
know what you
said
did there? Do you know what you have done there?
no. What did I do?
Okay, a minute. I'm going to Eziaku. Eziaku.
Sir?
Do you know what she explained now? Have you seen it?
Yeah,
Now,
that's
let me explain to you.
how I did my
That
own.
you know when I was telling you, I expect you guys to even ask a question. Let me pick it from this point. When we try to extract the columns, are you getting me? We did. I want you to listen now. We did this. Yes, for you to see all the columns that are available. Now, by the time we are trying to extract the numerical columns, I did double square brackets. So I expect you guys to ask
Which
me.
kind of network be this, God?
Yeah,
Hey,
so don't worry, just listen. But can you hear me, Mag?
yes, I can hear you.
I should just listen. So I expect you guys to ask, why did I do double columns? Okay, double square brackets. Now, what Mag explained, which you can also follow, is like this. For example, let's assume our elementary way, we did num column initially, num cos. You do this, and you put everything inside this column. Be seeing what I'm doing, you know. I copy everything like this, Control C. I put it here. I'm going to delete it too. So I create another column. This is the columns of the numerical data. If I want to grab the numerical data itself now, you know it's going to be num data will be equals to, let's assume the name of our data frame is I will just put num cones. Control C. Do you remember? Mag and Eziaku, do you remember this?
Yes.
Yes.
So look at the difference. What happened here is that when I initially defined the array at the list of the columns, by the time you are defining lists have to be, because it's more than one, right? You have to be enclosed within the two, within these two next square brackets, yes or no? So when you are defining it as well, I did not say because I have done square brackets here, I stopped. I just go and do df, then I pass this column. No, I also define another square bracket and I put the name of the column there. You remember when we started last week, when I was trying to select the columns, the data set that is having non-value, I did data frame, open brackets, data frame, then square brackets, the name of the column. That's what you are doing here. So if I did not impose the two condition, what is going to return is it will just go and grab all the rows element without the column header. So me putting it into two different into two square brackets, which is what I did here. It's like this is the first one, then this is the second one, and that's what I did here. Look at it. I initialized the first one, showing that grab all the columns name, and the second one represents put the values that you have grabbed from the data set. So this one will return it in form of the data frame the way it should be, and that's why you have it like this. It has grabbed it in terms of column, and also putting the corresponding elements in the column way they should appear. So when you are grabbing a data frame and you want to return it in form of a data frame for you, you must do two square brackets. If I've done one, what it's going to return for me, let's assume I just delete this. Of course, it will not even work. Why? Is because the element inside this place is more than one. So if I'm doing a selection from a column, from a data frame, and I want it to return data frame for me, from a column perspective, I will do double square bracket so that what is going to be given back to me will be the data frame the way it appears. Are you getting it now? So, and that is what these two steps did, which is our normal way. We've done this aspect as well. I will do like if I've done this way, my normal data set will still be turned like it's going to give me like this, the way I have it, without no problem. Which is instead of doing these two steps, this one and this one, I combine them together, and I did this two square brackets, put the name of the column, then put the data frame. It's going to return it back for you. Is it clear? Is it clear for the numerical? Hello? Are we still in class?
Yes, yes.
Now, when I go to categorical, same way, because you can as well do like, okay, for categorical, I can as well do this. Say cat column. Say cat columns. I can as well do this. Say, okay, cat columns. I want to put the columns. The cat column says just one. I copy this. Like we are following it one after the other. Cat column is just the station name. It's just the station names. I control C and I put it here. So if I want to grab the cat data now, cat data, you know, it will be the name of the data frame, then square bracket, and I put cat column. You know, this is what I would have done normally. You get the idea? So,
Yes.
so this is what I would have done. But here, when I infer, I only do one square bracket. Are you getting it? I only did one square bracket, and that's where the error is coming from. It's not seeing it as a data frame. Rather, it's just seen as an object. So that is what we did not infer. So this one, you can follow this approach as well, which is okay. Or since you don't want to, because what I did was just combine these two steps together, and I just do double square bracket, and I put the column's name. It's going to return it for me. Okay. So I jumped, instead of doing it like this, like you understand, I just do two square bracket and I put the column name. It's going to give me back the data frame. Is that clear? Is that clear?
Very clear.
Is it clear? So let me go and comment this one. I'm not going to delete, so that you can know, you can also take note of it. Okay. You can also do it like that. So this is fine. Here also.
Sometimes
Yeah.
I used to wonder, why do we put double this thing?
Yeah, double bracket is grabbing. You are trying to grab, but you are grabbing what and to return what. So single grab will just like it's just selecting the element alone. But if I put double grab, I want the column name at the same time the element in the column name. Just look at it. Look at that explanation that way. Okay. If I do single grab for one column name, what it's going to give me is it will give me the elements without the column header. It's not going to put the column name, like maybe the column name is easier. It's not going to name it. It will just grab all the elements in that column for me. Do you understand? But if I do double square bracket, it's going to give me the column name and the element under it, which is the complete data frame. Do you get the idea now?
Yes, sir. Yes.
So that is it. So that was what we passed, and that was where the stuff was returning error. Is that okay? Is that okay? Hello.
Hello.
Is that fine? I'm not hearing your voice. That's why I'm asking.
Yes.
Okay. So the next thing we move ahead is to now you've not done fit transform. So how to do transform? You can now see this is not cat data. cat data, right, will now be one auth dot transform, right? Transform. Then we pass cat data, right?
Yes.
Then cat data. Do you see it now? Okay. Is that okay?
Yes.
Good. So are we good now? Are we good?
Yes.
All right,
But
good.
I
So okay.
Yes. Can you hear me?
Yeah, I can hear you, Mark.
Oh, finally.
Yeah, go ahead.
I, I noticed something.
What's that?
I was doing this thing. When I if I don't worry, be doing. I will ask my question after the background noise.
Okay. So we are good now, right? So the next thing we want to do, we have our categorical, we have our what's it called? Our numerical, we have our target. So at this point, based on what I told you, you can therefore, because the next thing I want to do is now we have already got the target. The target will remain the way it is, no problem. So, but the numerical and the categorical, you can combine it together to become one data. In fact, you can combine the three together. You remember? Do you remember? Hello.
Yes.
Aha.
Yes.
So I have three different data now. I have numerical that we have transformed. I have categorical that we have transformed. Then my target is still my target. I didn't touch that one, right? So I can now concatenate. Yes or no?
Yes.
So can we go ahead and concatenate now?
Yes, we
And
can.
I have a new data frame. So what's going to change? So I want you to look at it critically. One of the values is an array, one is a data frame. So
Hello, can you hear me?
yes, I can hear you. Go ahead. Go ahead.
Okay, yes. I noticed that after doing all these things like this,
Mm,
and I
mm,
concatenate, I'll still be getting NaN. So the thing wanted to frustrate me doing this last assignment. So what I did was each of these each of my variables, I was now saving it and then importing it again. That was what I
mm.
now did, that I stopped getting NaN. I
No
don't know
problem.
why the thing is
I
doing
don't I
like
don't
that.
understand the why you are getting NaN. Do you understand why you are trying to concatenate? And the simple answer to that might be that you are not concatenating the way you should concatenate. There is row concatenation, there is colon concatenation. That means when you are saying x equals to 1 or x equals to 0, which we are going to explain now. Okay? Okay?
Okay.
So if you
Okay.
concatenate when it's ought to be row, you are doing colon, you have error, you have none rather, and the same and vice versa. So that was why. So let's take one after the other again. So I was asking you now, for us to concatenate this, maybe concatenation formula should have been pd dot concat, and you pass data frame, right, and do axis comma axis equals to 1 or 0. So these two has different meaning. This is the formula or the code you use to concatenate. Concatenate is telling you that you know what you're going to do. Put all the columns you want to concatenate or data frame inside this square bracket. When you are saying axis equals to 1, what you are saying is that I want to do it in terms of column. That means each of the columns of data set will stand on their own. I'm joining two data sets. Look at it like I want to add to existing table in terms of increasing the columns. That means if there are 5 columns before, if I do axis equals to 1, what I'm saying is that the table I'm bringing to add to this, it will combine with the existing 5, maybe making it 10. Maybe it's also having 5 columns. So each of the columns of this data frame will stand on their own. That's the meaning of axis equals to 1. But if we say axis equals to 0, we are saying that they both share the same column header. They are the same. The column names of this data set are the same thing. I'm only adding it in terms of row. I'm only adding it up because there cannot be multiple columns. Column name is unique across the data set. So if I'm doing as is equal to 0, what I'm saying is I'm only adding it in terms of row. I don't know if you understand it too. Hello? Hello?
Hi.
Do you
Hello?
understand do you understand what I explained now?
Please come again.
Okay. I said, for example, if you say as is equals to 1, what you are saying is that I'm only joining this data frame using column. That means column of the existing one plus the column of the new one to make more columns. Say, for example, the first data set is having 5 columns. The other data set that I want to join with it is having 10 data sets. If I use axis equals to 1, at the end of the day, I'm going to have 15 columns at the end of as my output at the end of the day. That means column 1, column of the data set 1 is not affecting column of the data frame 2. Do you understand? All the column will come together, and by column, I'm saying every column will show on their own. Do you understand the explanation now?
Yes.
So,
Yes.
but if I say axis is equal to 0, what I'm saying is that these two data sets have the same column name. Their column name is Eziaku, Ginika, Mag. That's the column name. So data 1 is having Eziaku in that order, Ginika and Mag. That's the data set 1 columns. Data set 2 also column is having Eziaku, Ginika, Mag. The same name, the same order. So if I use axis is equal to 0, instead of me having 6 columns at the end of the app, I'm going to have 3 columns, but the data set will have been added in terms of row. Maybe the first data set stop at 10. So I'm going to have maybe the second data set is going to be, let's say, 20 and 10. The first data set is having 10 rows. Second data set is having 20 rows. At the end of the day, I'm going to have 3 columns, 30 rows. Do you understand the idea?
Yes.
Yeah.
I'm going to have 3 columns, 30 rows. That means column remain unchanged, but the rows will have increased. Do you understand? Like you are adding something from the bottom. That is what axis equal to 0 means. I'm adding from the bottom. So it's just going to be, and what makes it to be so is because they both share the same column name in the same order. Not that I have Eziaku, Ginika, Mag in one. I'm having Mag, Ginika, Eziaku, the other one. No, it will not add. Otherwise, you have error. You have the non, because at some point, it will be saying Eziaku in one. You will not see Eziaku in the other one. So therefore, where did not see to go to plan there? Do you understand?
Yes.
Please get that. Okay, right? So that's not even where we are going. Where we are going now is that look at the 3 data sets we have. I want you to pay close attention to it. The first data set is the numerical. Yes, we have done this numerical now, but this numerical now is giving us what? An array. Is that not the output?
Yes.
Good. The second data set, which is categorical, what was the output? How does the output look like?
Data frame.
God bless you. So, by concatenation, both of them should appear the same form. Yes or no?
Yes.
If you want to
Yes.
concatenate, they must appear in terms of data frame. So, what is wrong in these two now? Can you spot it? Yeah, based on what I've explained, it's very simple.
The
Which two?
the
Say what?
categorical and the numerical be.
Yes, categorical and numerical. These two, by concatenation, we want to add them together. We want to join so that we can have a larger data frame based on what I've explained. So in the numerical, the output of what I converted is an array. You can see it here. In the categorical, the output of what I converted is a data frame. Can you concatenate like this? The answer is no,
No,
because they
No.
are not in the
no.
same format. So the
Yes.
next thing is I'm not asking you what can you do for them to be on the
Dot
same.
value.
Okay, if I do the value on which one?
On the categorical categorical data.
Okay, so they will not, both of them will not be on array. They'll be
Yes.
an array. So
Yes.
can you concatenate an array?
Change the numerical to data frame.
Simple. That's the answer. Because you know, whenever you're concatenating, this, I've explained it, both of them must be a data frame. Do you understand the idea? So before you can concatenate, even if you want to concatenate 500 data frame, there must be a data frame like rows and column. So if one is not in that shape, it is just your duty to convert that one back to that shape. Are we together, my Eziaku?
Yes.
Yes.
Good. So it's nothing is changing, right? So it's just for you to take it back, and that is what it's going to be. Do you get the idea? So it means that if out of these two, one, this is the only one I'm having problem with. Adding it also come out in form of a data frame. I'll not have any issue. But it's coming out as an array. So there's need for me to convert this one to data frame. So that once it's in data frame, I can concatenate data frame and data frame. Do you understand it now? Is it clear?
Yes.
So let's do that. So
Yes.
I'm going to create the stuff here. Please take note of that. So what we'll do here is convert the numerical data transformed to data frame. Okay, so let's run that. So don't forget this is it. So how do you convert? To convert, you just do pd.data frame. Remember, have you forgotten?
No.
So you can see column data, it does not matter. I can still use the same name. It's not, or maybe for it to, so that I don't override the data df. Okay, will be pd.data frame. Do you still remember this?
Yes.
Then you pass the numerical data because this is the one you want to convert, right?
Yes.
Put it here. Voila, right? Comma. What should be the columns? What's the columns?
Numerical. The name of. Eh?
Yeah,
The
you're
name of
correct.
those variables in numerical data.
Exactly. So you now know that we can do two things. Just don't forget that we have defined. Did you define it? I didn't be with it like this. You know, we'll have just called num columns. Okay. Any question?
No.
So
Yes.
you understand? So I'm going to open this one. I will define this one. I'm just going to open it and I want it. Okay. So that because this is what you need this column to represent the conversion, right? So instead of, I don't know if you're getting me.
Yes.
So it's going to be num columns. So columns will be num columns. Columns will be num columns. Do you understand what I did now? Num.
Yes.
Exactly. Do you understand?
Yeah. Yes, but
Me, I used to always list that place where you put columns equal to non-columns. I used to list all the
Yeah,
columns
you can
again.
list. Yeah, should you use list? Should you list them out? Which
no,
one
that
No,
was
we
like?
can
not
leave it like this.
Okay. So Mezako was saying something. What are you saying?
yes. Me, I didn't do my own like this. I think I've seen why it was giving me NaN.
Yeah, to give you an N. I also
When
know.
I now
I also can see it now. Yeah, to
yes,
give
when
you
I
an N.
now saved it with a PD, like as I saved it as data frame and imported it back as the data frame, that was when it's now concatenated very well without NaN.
Okay.
Oh, I
I'm
thought
just
the magic. Shit. I thought the magic was in saving and bringing it back. So it's the
I
data
am telling
frame.
you.
Hey, God.
So see the two of them.
That is stressed us, Ola. Seriously. Oh.
You see these two people. You see
We
now.
did it more than 100 times. After doing it to bring out NaN. Like,
Yeah, yeah, but it's not bringing. That's the logic. I told you that you just need to relate. Once you know what you are doing, code will not lie. So it's just for you to follow up. Okay. So even if I didn't use num columns there, what I can do, just like what Mark said, just copy the whole of this thing. All right, copy and go and paste it there to convert. But this is like a childish big that you like. That's what I say. I saying that if I augment a list, I don't want a column here. I still have to go and define. Why don't you just define the column and just put it? So anytime you change anything here, it will change across the code. You get the idea. So that's it. Do you get it now? So I've been able to move away from an array to a data frame. Is that clear?
Yes.
Good. So we now have data frame now. I can concatenate. Yes or no?
Yes.
Yeah, let's go ahead. So it's simple. You just have to follow them one by one. That's why it's not, you don't cram it. You know it, you know what to do. Okay? If you have crammed it and you get lost, just know, understand what you are doing. You go back and check. Error is part of the programming, okay? It's not an issue. So let me this is an explanation. I'm going to comment this out. So we create another column here. We say, oh, yeah, let's concatenate. Concatenate the num data df and then and then the cat data, the cat data we call it, your cat data, and then target. Don't forget. Okay. You know, you
Yes.
have remember, so that everything can appear as a single, it's going to appear as a single column that you can now save, which is going to be a clean data that you have converted. Okay. So it's too small. So that I can now say clean. You know, do you remember? So clean, because this is clean because you have preprocessed this. This is what you are going to use for the model. You get the idea now, because you have transformed it, you have done what you need to do. Are we together? Are we
Yes.
together? Clean df is equals to pd.concat, then in square brackets, then I will call all what I wanted that you want to use now. I need numerical, which is this one now. Okay, not the array one. If you put the array one, we're going to get error. Okay, I come here, I paste it, and put inside square bracket too. Then comma, categorical will follow, which is this one as it is now. Okay. Oh, okay. I'm still going to show you another thing before I run this code. Comma. Then I put the target. You know, everything have to be together. Do you remember? So that you can use the value at once. Blessing.
She's not here.
Oh, yeah. Maybe our network.
Oh, you mean Ginika?
Sorry. Oh, sorry. Blessing has entered my head. Yes, Eziaku. Sorry. Eziaku. Okay. So then I will do axis equals to 1. Why am I doing it? Because I want everybody to appear. Numerical is different from categorical, and categorical is different from target. So everybody should be on their column. Is that fine?
Yes, sir.
Okay, good, right? So, but something we have to check. Now, let me quickly tell you. It's very good that we follow that process. What happened? Now, I want you to check something for me. Check the index of, let me start from the target for you. Please be observant, be very observant at this point. Now, let's without, okay, look at the original data of the without. This is the original data of the without. Right, let me make it so that you can show something clearer of the without. I think we didn't override it. So if I run this one, I don't have any issue. Okay, look at it now. If you look at the index of the without, what did you observe?
Started from 5.
Yes, no problem. And continue. Is it sequential? Does it follow a pattern?
No, it only picks the ones that are without.
Yeah, no, no problem. I want you to look at the numbering of the index. Are they sequential? Sequential
No,
means
not at all. They are not.
they are
6,
not.
7, 8, 5, 6.
5, 6, 7. Then after 7, normally it should be 8. It jumped to 16.
Okay.
There's a problem.
Yes.
It's not something, but it is important. If you don't do it, it can also make you to be getting none when you finish concatenating. So already, please, already your data set that you are working with, you extracted it from somewhere, don't forget. And when you extracted it, you are going to be extracting some column away from the original. Maybe the first one you pick, maybe you neglect the first row, you neglect second row, you went to go and pick the third row. The next thing going to pick maybe is at row 10. So you will have picked row 2 as 2, index 2, and the next thing going to pick is index 10. But between 2 and 10, there are so many values that he has escaped. And he did not escape it by intention. He escaped because that value is not existing in those rows. Do you understand? So it will have jump indexes. So which is normal. It's not your fault. That's what you have selected. But the right thing to do is that anytime you select something from a data frame, you always reset the index. Resetting index means that, oh, I know there might be some jump while I was trying to select my data. So reset it means take it back to the original way it should be. Are you following?
Yes.
Are you following? So please write it somewhere. When you do selection in data frame, there will be some jump, of course, which is normal because everything will not be the same row now. One can be at row 1, the other one can be at row 100, the other one can be at 1 million, and it's going to be using the row name, the row number, to be picking it and be putting it in a new data frame for you. You're going to see row 2, row 100, row 500, 1000. Those are the position is seeing those elements. So pandas will not understand that I need to reset it for you. If you didn't tell it to reset, it's showing you so that you can know that he picked this first row from row 5, he picked the next element from row 6, he picked the next element from row 7. The next one he's picking is at row 16. Do you get the idea? And the next one he's picking is at row 17. Do you get the idea? So it's not his problem. It's now you to know that, oh, I've selected. I have made a disjoint. There is a discontinuity in my data set based on how it has selected. So you need to always reset it. If you reset it, you take it back to original form. Are you getting the idea? So 2 things you can do. Before you start working on data set, you can reset it. And even if you forgot, when you finish doing your whatever, you can still reset. It does not matter. The only thing is that don't forget that you should reset. Otherwise, there will be a problem. And at the point when you are trying to concatenate, maybe one of your column is having 259 based on how you grab the element. But the other one you want to join with is having 244. It will be telling you that I have 244 here, I have 249 there. They will not match to put you any and there for you. Do you understand the idea? Because you can't see it, you can't see the correlation. Are you getting the idea? Hello.
Yes.
So always reset. So if you want to save you can quickly reset at this point before you start using the data. Or if you have forgotten, you can reset in between your work. Nobody's penalizing you. Resetting is just to take it back to position. Okay? So I will not reset at this point. Let's reset after we've done the transformation. Because even when you do transformation as well, it can change the position. So always reset at the final stage when you're not doing anything on the data again. So that what you have will be the final. And that's what's going to be taken in his head. Are we following? Are we following?
Yes.
Good. So now, what did we do with numerical? Look at numerical we selected. You can see. Look at the numerical. Index is not right. Look at the categorical. Index is not right. Can you see what I'm saying? Index is not right.
Yes.
Are you following?
Yes.
Look at the target. Index is not right. Do you see the tick selection? Index problem. But the data are correct. It's our own duty to reset after we finish our job. Are you getting me? Do you understand?
Yes.
I've just shown you that
Yes.
to see the problem. And this
Yes.
was coming from how you selected, because there's no way you can perform any magic. This thing you selected is coming from the original selection. So anything you're going to be picking will be affected. You get the idea. There's no problem. So that's why I said that you can decide to do the resetting at the beginning, but it's always even if you do at the beginning, immediately you do transform or you do encoding, it can also change the index. So don't reset at the beginning. When you finish your whatever you are doing, then reset. After you reset, then you concatenate. Is that fine?
Yes.
You understand?
Yes.
Good. So let's go ahead. So the only thing that is missing is we need to reset. Normally, numerical data, when you do standard scalar, standard scalar, minimax, or normalizer, those ones are very good. The algorithm is built to do auto reset for you. So any numerical transformation will automate and correct the index the way it should be. And how do I know? Look at when we did transformation. Can you see 0, 1, 2, 3, 4? Is that what numerical was having initially?
No.
Are you seeing the
I
beauty?
see.
You see
Yes.
now, initially it was 5, 6, 7, 16, 17. But when we do numerical transformation, did it transfer? Did you change the index now?
Yes.
So that one is clear. So I don't need to do reset for numerical. Let's go and check categorical.
How did you do the reset, please?
Where?
For the numerical.
Numerical,
No,
we
it
said
was the
numerical, when you are doing transformation on numerical, those algorithm on numerical transformation, standard scalar, minimax, normalization, has the capability of doing the resetting automatically. And that's what I told you. I did not do anything. We did array, we converted, and we have our insert reset, index reset, right?
Okay.
We cannot do anything.
It's
It's
just the
automatic. It's automatic. It will do it for you. Okay? For numerical. But let's now go and check categorical if it's the same thing. Do you understand that now?
yes.
Okay, good. So let's move to categorical. Now we are on categorical now. When we finish encoding, did anything change in the index? Did it change the index for you?
no.
Aha. Can you see now? Is that this is not magic, it's obvious, right? It did not change.
Yes.
So it still give you the way the index were. Okay, are you following me?
Yes.
So therefore, there is need for us to reset index in categorical. Are we getting it?
Yes.
Good. Yeah, let's go ahead. So I'm taking, so these are fundamental that you need to know. Okay, because this one is you are preparing a work. So these are steps that you have to follow. So what do we do? Reset. You always do it. Reset index of the categorical, and the target. Why? That target data frame. Because they are the one that was not done automatically. Okay? Okay, Mag.
Yes, I can hear
So
you.
the numeric Ezeaku, are you still there?
Yes, sir.
The numerical one has done it. We don't, even if you want to, if you write the code for numerical, it will still not change anything. But just know that numerical is already done. But both targets, because we don't even touch target. Did we touch target? We didn't do anything on target. So target will still remain, don't forget, it will still remain untouched. That's why you need to reset it as well. Because it didn't do anything. So it will remain the way it is. But assuming we also transform target, maybe like numerical, whatever, maybe it will have, but we didn't do anything on target. Target will still remain with the errored index. So you need to reset it. Then the categorical that you have also seen, you also need to reset it. But numerical is already fixed. Do you have any question? Do you have any question?
Yes. No.
No, okay. So target, therefore, I start with target reset. This is the code to reset, copy the target data. You don't need to rename, just call it the same thing. So target data. Yeah, voila. So target equals target. Dot reset underscore index, then drop equals true. That's all. This is all you need. Immediately I do this, you have reset. What do I call it? This, you can call this thing another name, but I mean I just want to still use the data, the name of the what we are familiar with. You can start to call it another name. Okay. So this one is the name you want. This is data.
Okay.
This is data itself. This is what you want to reset. So it is data I want to reset dot reset index. Why this is the name I want to give to it. Okay, you remember variable, now. We have gone out of this stage, right? I don't just want to give it another name, so I don't have so many names. Are you getting it?
Yes. Yes.
So, and you inside the bracket, you do drop equals to true. You must do this. Drop equals to true is important. So if I copy this now and do this now, you're going to see the difference. Please know this difference before I run it. Look at the original one. No. Original one was 5, 6, 7, 16. Do you agree?
Yes.
So let's go and run the reset now. If I run this now, has it been reset?
Wow. Yes.
Yes.
So let's do the same thing for categorical. Are we good?
You're welcome.
Yes.
Okay, blessing is around.
I had to join. No,
Because I want to see that nan. I must see that nan. No.
That we have gone away from. We are out of land.
Is Mark that was gisting me. I don't know why I was the only one getting nan.
Okay.
But it is well, I'm seeing it now.
Okay. So we'll do the same thing for the categorical. Yes or no? So for the categorical, the same way. Cat equals cat. I just decided to use the same name. Don't forget dot reset underscore index reset index drop equals true. Voila. So if I call this one now, please let's go and observe what we initially had. Okay, this is the original one. Can you all see it?
Yes.
So let's reset it. If
Yes.
I reset it, so what should we have? Can you see?
Yes.
Do you see?
Yes.
Has it been corrected?
Yes.
So therefore, look at number of rows. For categorical, they are 4493. For targets, they are 4493. They are the same now. Are you getting it?
Yes. So that thing too can contribute to nano.
Yes, now, because it is not there.
Good.
You must do the reset. So that's the logic. C'est clair?
Oui, c'est clair.
C'est clair. C'est clair.
C'est bon. Yeah, all of you now know French. Hey, God, when am I going to learn this French? My father, my God. See people
If
tell
I
me.
hear you read the Baba that is inside the French itself.
Listen, can you hear what they are saying? Are you joining them, or you are saying the other something that is different? I trust you.
I'm joining them. Or you that used
Well,
to
I
write
expect it before. I'm just
French
whining.
inside your
I expect
email.
it before that you join them. So you can see now for the medical, all of them is now 4493. You see, 4493, 4493. Is it clear? This is now how you can now go back now and concatenate. If you didn't do this
Yes.
step, you might have error. Is it clear? So let's now. So if I now run this guy now, I'm fine. Okay.
Yes.
Okay. So because they both have the same number of rows, what is different is the column, which is not problem for me. I want to have more columns. I don't have problem, but the rows must be the same thing. Otherwise, if this one is 400 columns, this one is 500 columns. The remaining one of the it will be none now. Do you get it now?
Yes.
All right. So am I good to run the code now?
You're very good.
So clean underscore df. So if you run it now, so this is 50 columns now. Make the data. My target, everything is fine. Okay. So you can save this now. This is a clean data now, okay, that you can save based on what we have taught ourselves.
So there's no nan. Hey.
Just take time to watch the video, you'll get it. We did with that anyway. Just that you're not in class. But I told you, you're just doing something that is wrong. So at some point.
Okay,
Yeah.
no problem.
But there's no issue, don't worry. Is it clear now? At least up to this level, Ezekiel and Mark, did you get it? Blessings just joining
Very
us.
well.
So this is it. It's concatenated now. So this is now the data frame now I can now use to make my model. Okay? Whereby you can now do your features and targets, X and Y. If you want to turn it to values, it's your choice. If you don't want to leave it, just do whatever that is remaining. Is that clear? So let's do the next thing is you can also, okay, I have a data that is clean now, really already pre-processed. So I can do select features if you want. If you don't want, you can run it like that into data frame, no problem. Select features and targets. Your target is still just that you are redefining for purpose sake. So your features will be your X now so that you can maintain uniformity, and your target will be your Y, okay? Be your small y, okay? So that I can maintain uniformity of purpose. You can put anything, but let's just say we are using. So for us to select my features, so it means from here up to station names take now will be my X. My only Y will just be flood. Is that clear?
Yes.
So you remember this one, so that it's the same thing we are doing. Ezekiel, are we good? Ezekiel, are we good? Isaac
Yes,
is not.
sir. I'm here.
All right. So you understand the approach now. So if I want to
Yes.
do, can I do your values to array if you want? But let's say we have, that's the method we had adapted. Let's convert this onto array now. Convert to array, if you just to fulfill the righteousness of what we are familiar with. So it's going to be clean df, the data set I want to use. Like this is an array type of this dot values. Voila, right? That will convert it, and then I'm good. So if I pick this has now turned to an array, Control C, the first, so show me the first element of the array. So this is okay. See now, so it's now an array. So away from data frame. So from here, you can now select your x and y. So x will be x is equals to array array of what? Hope we have not forgotten. Oh yeah, array of what? Hi. Oh yeah, array of what? Oh,
Pom. Semicolon.
I've done the first semicolon, the second semicolon. Of what?
Of -1.
Okay. Then y will be clean df of everything in the row, comma, -1. Yes or no?
Yes.
Do we understand this one
Yes.
now? Okay, good.
Yes.
So good. So we have been able to get that out. So in this case now, if I should run this, my x and y has come out. So I can now do train test split. Are we good?
Yes.
Yes.
So let's do the train test split. Train test split. So yeah, Blessing, I've been calling you anywhere you're not in class. You can imagine. Give us the library that we always import. What we want to do train test split.
She's no longer in the class.
Okay, just flew in and flew out. Oh yeah, Meziaku, tell us the library we're going to import for train test split. Yeah, we're waiting for you. Hey, some people are looking at Google.
No. Is it not model?
We'll look for
from sklearn.
I'm expecting you to tell me tell me the library from sklearn dot
Model.
model what? No. Model what?
Unica, what is it? Say it.
Model selection. Import train.
logistics.
No, not only logistics. We want to do train test. You are saying oh my god. Exactly. Don't come and kill us in this class. We want to do train test. You are saying, no, it's not only logistics. You hear me? Hello?
Hello, don't mind me.
Hi.
No, it's not only logistics we are going to. We'll do trailer. This is easier.
Or DHL.
Yeah, or DHL. Let's do seed is equals to which seed should we use?
15.
What does this seed does? I have explained it many times. What is it doing?
So you keep getting, it keeps picking the same.
Yeah, it is called
reproducibility.
It produces the same results anytime anybody runs it. Okay, seed is important so that you get the same result every time you run the cell. Okay, reproducibility. Reproduce. Then
please explain the reproduce very well, please.
That I've explained it many times. I remember very well. I explained many times. CDs. The essence we use seed is that you can get the same result anytime you run your cell. Otherwise, if you not do seed, it's random. So he will randomize the first time, give you one answer. If you want it again, he's going to randomize again and give another answer. But if you want to be getting the same answer, because it's going to be the same thing that you has picked the first time, it's not going to change it. That's the essence of using seed. Reproducibility. Reproduce the same result every time. Okay?
Then why do we put 20 or 30?
It doesn't matter.
Okay.
It's just a number. Are you getting my point now? You're just putting a peg to it to say maybe that seed is like at randomize the data for every 10 elements, 10 batch. So it's going to grab it and keep that 10 for you. So if you say 20, it's going to keep 20 samples of that data. If you say start, it's going to keep 30 samples of that data. So anytime it's working and you are running the cell again or the notebook again, that 30 has already kept it for you. It's not changing it. Do you get it now? It's just like taking sample that is keeping for, it can be anything. Okay. So let's just see this 10, right? So we do x train, comma, x test, comma, y train.
Sorry, I want to ask a question.
Yes, go ahead, y test.
This X train, X test, must it be capital letter like the X we used in our this thing? That place we wrote clean DF.
In fact, you can put this one, I can put your name. Is
In
that
which one?
Is that this thing you don't forget this one is a name, it's a variable name, you forgot it. That's a variable name. What I just trying to use just to follow convention. You can put mag 1, mag 2, mag 3. You are the one that what is your mag 1? You know that your mag 1 is train. Why we are doing this separation is that the first one is the train. The only thing that matters is follow the order. The first one will always be the train set. The next one will be the test set for X.
Okay.
Why the one so that you don't miss it. This is the order is what matters. The name does not matter. I can put Larry 1, which is my train. Adegoke, my test. So I'm doing this, it's going to be Larry Adegoke. So if I'm getting to Y, it's going to be Y Larry, then Y Adegoke. Do you understand the idea? So it doesn't matter.
Yes.
So train, test, split. The only thing that matters is the order X, Y. So that's what you need to maintain so that each of the sample you are picking, you know that the first one is the train set, second one is the test set, then Y in the same way as well. Okay? Train, test, split. Is that clear?
Yes.
So I put my capital
Yes.
S, small y, based on what we have obtained. Test size equals to what percentage do you want it to use?
0 point.
What does it mean? Explain.
0.3.
What does it mean? Yeah,
I don't know. We've been using 0.3 and
I've
0.2
explained this thing I've explained it more than dead. I too explain it. I too explain now. What does it mean? Test size. What does it mean? Okay, let me take it again. I've explained seed now. Again, I'm going to explain. When you say test size, you are telling in a population there is sample, right or no?
Yes.
This is like a sample size that in my data set, which is like 100%, I want you to keep certain volume of this 100% to be used as my sample, as my test rather, so that when I build the model, I will use that sample to test the performance of my model. That was why you're having test here. Okay? Test here. That is what you are keeping. That portion you want to keep is to say out of 100% to keep 20% for me. So it means that
Yes.
the model will learn 80% of the data. So that 20 has not seen it, he didn't know it. That's why you're using train. The train will be the 80% that remaining will be for train, X train, and for Y train. Why the remaining 20%, based on if you are using 0.2, will be for test. That means what it means is that when the model is learning, he did not see, he didn't expose it to that 20. That 20 is kept somewhere for you. Are you getting the idea now?
Yes.
Because when you build a model, the idea is that by the time you bring external data that the model has not seen before, you should be able to perform. So you are trying to keep this junk of this data set somewhere and say that, you know what, don't see this one. Build your model, learn your learning, go to school and go and study microbiology with this 80%. When you graduate, you want to put to the lab and say, produce paracetamol for us. Are you getting me? Giving you the external data or external material to produce paracetamol. You that you have gone to school, you have learned different ways of producing paracetamol. If they give you the right information, like you understand, you should be able to make that paracetamol. So if you cannot make that paracetamol, that means you have not learned anything in school. So we are keeping that 20% somewhere to say, you know what, just keep this 20, very small amounts. Do you understand? Just keep it somewhere and say, when my model has done training, if I give this 20% to this data, I give 10%, I give 50%, anything you want to use, the model should be able to behave and learn and give you fine accuracy. Are you getting it now?
Yes. Please, I want to say something.
Okay.
Now, this means that, first of all, before we pick the data set that this train test is working with, is not the whole 100%. Please reduce your noise. It's not the whole 100% data, because our seed is picking 10 randomly. Abi?
I
First,
didn't get that line.
okay. These data sets that we are doing, X train,
Okay.
X test, and the rest of it, is not the 100% of the data set to begin with, because we already randomized with seed of 10.
No. This one is just telling you that out of 20,000 data, put them in 10. Let's use that example. 10. You will go and do it in like that means use 10 divided by 20,000. You should have around maybe let's say 2,000, right? Let's say for example 2,000 data sets. So each bucket will contain 2,000 entries in 10 places. That's what this one is saying. Okay. Now,
Yeah, okay.
what this one is saying is that look at what you have supplied. You have supplied the whole 100. Now X and Y is the whole 100%. Yes or no?
Yes, no, I understand the test size.
So this one is a bucket of randomized, because if you did not do this thing, even if it's going to, let's assume you didn't put 10, you didn't define the seed. Look at what's going to do. It will go to the data. First time that he run through the data, maybe he picked the first 5 above to train your data. Let's assume. By the time you want to decide again, you can go to the last because it's random. If you want to take, you can pick the entry at the middle. You don't have control over it. It will be going, because it's randomized, it will be going and be doing what it likes to pick this sample size from. Okay? Because it's randomizing it. So
Okay.
you want to pick the first 20%, you can pick the first at the beginning. You can go to the middle, pick the 10% that you have indicated. You can go to the bottom, pick the last 20%. Do you understand? Which is not a problem. But the implication is that if I have built this model without not defining the seed, so this thing we maybe pick the first 5, then I build my model. My model has learned without the first 5. Are you getting the idea? Without the first 5.
Yes.
If I run the same notebook again and I don't define the seed, it can now go. Maybe that performance as at that time was 90%. Maybe when he now went, I'm going to pick the last one to keep for you. You understand? So when the model is not learning from the last, the behavior will be different from when it was learning from the first. Do you understand? So you are likely to have different results. Do you understand the logic? So, but when you have fixed it, you are saying only show me random sample of anywhere you pick and keep it. Even if you want the model 500 times, it's not changing that sample is keeping for you as your test. Do you understand?
Yeah, it's clear.
Yeah, it's clear. So let's use 20%. In fact, this choice is, let it be between 0.1 and 0.3. That is 10 to 30%. Especially when your data is very small. 20,000 is a small data. If you say you go and increase this, that means your model will not be learning. But let's assume you take this one to 0.5. That's 50%. You're saying keep 50% of data for me and use 50% to train. Do you believe that you learn anything? It only learn average.
No.
So be careful of the choice of let it be between 0.1 and 0.3. Especially when your data set is not much. Okay.
Yes.
So let's run this. So we have gotten the X-ray, next blah 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 that we wanted. So you can now build them. You can then send the model to school now. So train the model. So be preparing. I'm going to call you how to initialize the model. So be ready. If you want to go and be Google, train the model now. Which model do you want us to use? and then you initialize it, train the model. So by training model, it means you are fitting, does fit. If you pass the dot fit method, this guy will train. What is this now? Why is it now? Turn it to you. Are you drunk? So train the model. Which model should we use?
Logistic.
Logistic model, okay. All right. Yeah. Who will help us with the? Don't forget to logistics you are using. What you want to predict is only you are building a model that will predict. Look at where we are still going. You want to predict the none of the other one, no. But we are building this model so that it can have the capability of predicting the one inside that one. Do you understand? Don't forget to. Yeah.
Yes.
Yeah. You have agreed. You want to use logistics. So yeah, tell us. And again, why are you using logistics? Why are you using logistic regression?
What did you ask?
Why do we want to use logistic regression? Why nonlinear regression?
Because the target is 1 or 0, Abi? Yes or no, something like that. When it has to do with 1 or 0 or yes or no, something like that.
All right,
There's something.
good. Because the classification problem, that's the right thing you say. Because the project at hand is classification. You are classifying as either 1 or 0. So anything that has 2 or more options in terms of you are thinking is, can it be yes, can it be no, can it be 1, can it be 2, can it be greater than, less than? All those things are called classification problems. Okay.
Okay.
So for any classification problem, logistics, of course, that's the go-to. So yeah, let's use from sklearn. Yeah, Mag.
Boss.
Yeah, I've helped you from sklearn dot want to
from sklearn dot. Can you hear me?
we are loud and clear.
Okay. From sklearn dot linear model. No, it's linear model.
Yeah, yourself, you are good. Ah, c'est bon. Ah, exactly. We see that Mag is moving fast. You be checking. Be checking Google to give us a model name. Be checking Google, yeah.
She's not checking.
Do I even know if she's checking or she's not checking? you are minding me. Logistic regression.
To train. She have learned.
So
you say?
I say we've trained you now. Say we are doing training. We are training the model, so we've trained Mark. So she learned.
Oh, so log reg, we initialize this, right? So
yes.
Log reg, then log reg. You see, so use it, yeah. So it has not learned anything. You just initialize. For you to learn now, you do fit, and then your model will learn, right? So log reg dot fit. So what do you pass inside the fit?
X train and Y train.
C'est bon. You pass X train, comma, and Y train. That's what I told you. You can see that we did not touch the test. What you are saying here is that I have not seen, he has not seen anything under the test. Test also is 2 different values, but you didn't pass it. So what is learning from is only the train, the 80% that you wanted to learn from. Do you see it now, Mag? The 80% is what is using for the train.
Yes.
So it will have learned 80% of the whatever. So the model has learned. So for us to know if it has learned, what do? We make predictions now. Yes or no?
Yes.
So let's predict predictions with the model. Voila. So how you do this? So I can say ypred prediction equals to log reg log underscore reg dot predict. What do you pass inside the predict now?
X test.
X test because he has not seen. I see that that's why you're using. That's why you use the test to test. The essence of this is just to test it to see if your model is doing well or not. Are you in a conference?
Can we do this thing?
Who is in the conference?
Ola,
Yeah.
can we activate this thing without even bringing out any test size
I didn't hear you. What did you say?
of them? Can we train all this thing without bringing test size?
Yeah, you can. You can. That means what I'm going to do is just the X train and Y train alone. We'll
Okay,
discuss this. That means what you are saying is that you are confident that if you this model you are building will perform. If you didn't do that, there will not be any room for you to test. To know if the to know the accuracy of the model. If you didn't declare the test size, okay? You're only going to have X train and Y train alone. That means I'm using the old data to train. I don't want to test.
And we are sure.
And you are sure. But can it be true? I don't know. Maybe you are the new scientist that will now say, oh, any model I pick, I'm okay with it. Because, okay? Do you understand?
Yes.
So, basically, do you get it? So, the essence of this test, Y test and X test, is just for you to be able to check the performance of this model because some algorithm might not work the way you wanted. And if you didn't create room, you won't know at this stage, except you have to go and get the external X test, extra data outside to test the model. That means if you build your model finish, you need to wait for people to give you data to test the performance. And maybe at that time, you don't even have deadlines already approaching. And they now bring external data. Model is now performing by 50%. They will now ask you, it's because I did not create. They now say, the essence of doing this is to be able to evaluate, keep checking, and keep seeing what you can do. Why you wait for external data? Do you understand?
Yes.
So it's not compulsory that but it's necessary because it will allow you to test the performance of your model while you are trying to build it. Exactly. Is that clear?
Yes, sir.
All right. So can we do the prediction now?
Yes.
Let's do the first 10. You remember this one now? Well, okay. That's the prediction. Let's compare with the grand truth. What's the grand truth here?
Y test.
Exactly. The grand truth is Y test.
What did you call it? Grand truth.
Grand truth. Grand truth. Grand truth. Let me write it for you. Grand, normal grand. This is original. That's the meaning. Grand truth. This is original value. Okay? That's the grand truth. This is coming from the data now. This Y test was from the original data. Is that not? This was prediction from the model. There are two different values. So this is the grand truth. This is like the derived or predicted value. Do you get the idea? Hello?
Yes.
So that's the grand truth. And we say they are the same thing. Are they the same?
No.
Are you sure that you know? Whether
Okay. It's the same. It's the same.
performing
It's the
rightly
same.
well. Performing rightly well. You see? Everything is true. Can you see?
Yes.
Do you see now?
Yes.
So the model is performing 100%. So this was manual test, but you need to test the stuff. So let's do the accuracy score. To know just score your model, right? You can score your model now, should be.
Yes.
Then let's score the model so that you see the performance. But you can see that it's working. It's like 100%, but let's just do evaluate the model using your score method. Evaluate the model. You're still going to do more of this evaluation. So your normal score. Who is in the meeting? Mark.
Boss.
No, I'm not boss. Who is in the meeting? I'm hearing some underground.
Yes, I've put up my mic.
We are the one. Okay. Next test. Evaluate it on an unknown. That's what you are doing here. I want to evaluate the performance of this model on an unknown data because he has not seen these two. So I'm basing it on, okay, you know what? This is what you have not seen and test it. That's what you are doing. Is that clear?
Yes.
Exactly. So I'm saying score this model based on data he has not seen. And what he has not seen, he has not seen test, he has not seen maybe Y test and X test. 99%. Is it good or is not good?
It's good.
It's very good.
So model is fine. So you have built a model. Ah, time has even gone. Voila. Hey, Jesus Christ. So you have built a model. And what's the model name? The model name is logreg. So we've been able to build the model. The built model now, which is another assignment I'm going to make. The built model is log rec. So I'll call it log rec. So this is the model. So is the model that you now want to use to predict. Now, let me tell you what we now do. You see now, we are done with using the data that has no none, okay, to build a model. So the next data we need is the one with none. So none, yeah, this is what we need. We now need this one now. I'm going to explain now, because this will now be like the external data that the model has not seen before. And if I put it there, it will predict it. Okay? Okay?
Yes.
Okay.
Yes.
So do you have time for us to go through it, or you go and do it as an assignment?
Let
We've
us
already
go
done
through
it.
We did it.
No, we did it in the last assignment already.
And it's predicted the why you predicted.
Yes.
Ah, why am I not seeing it? Okay.
Me, I didn't do it.
Okay, this is my gun. Oh, where is the prediction? What did you predict? Okay, now why predict? Okay, let me see what you did on the. There's a problem. Can we do it? Can we do it? Or you go and try
Yeah.
it? Yeah, I've
You
seen
said
a
there's a
problem.
problem
Do
somewhere.
it.
Yeah, yeah, I've seen something that you
Eh.
did that you don't need to have done. Yeah.
Okay.
What you did here is you are training two different models. Look at what you did. You did. I'm seeing next test. Why did you do? You have to. Why do you have to do this?
But I shouldn't have done that.
No, you shouldn't.
Okay.
Why do you have to do
Let's
this?
do it. Let's do it too.
You shouldn't have done this. You can see what I'm circling.
Yes.
So yeah, let's do it. Let's quickly. It's going
Okay,
to be
let's
fast.
do it.
If we didn't finish, you go and complete it, but it's going to be fast. So now the assignment is, I mean, the solution is, I didn't even ask you to go and predict. I just said, build this model. See, this is where I expect that. I think it was a exactly got to, this is the model. I think we are using the same notebook. I will have just used model now to work on.
Oh,
So this is the model I wanted, which all of you got.
okay. That's
So
why you wanted us to stop.
yes, I
Oh,
said build the model that will that is capable of predicting the NaN. So the other thing we do in the NaN. So let's quickly go ahead. So do you understand of this level now?
yes.
So the next thing is now that we have a model trained to predict the flood without the flood, yeah, then it can be used on the data set with NaN so that we can predict the NaN value. So I'll just teach you now. Let's just finish it so that I don't want to time. Is it 9? It's almost 9. I'm having a meeting by 9. Okay. We have to be fast, but please hope you can see me. So this is you can see my screen. This is the NaN,
Yes.
right? So everything you have done, this is the pre-processing. Everything you have done in the process of predicting your building the model is what you're going to do, except that you're not defining anything. So don't forget, we first of all look at the process we follow. You are going to follow the same process because this data must be prepared before you can use it. The same preprocessing method that we follow. What do we do? So the preprocessing method is starting from, we don't need all this one. Starting from select the columns, blah, 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 vis-a-vis, select the columns. After that, we standardize. Are you seeing it now? We categorize, encoding, we reset. That's what you need to do so that the data can come into this level. If you need to get this data, you can make your predictions. So you don't need to do select X, Y, K. This is the only thing you need to get to so that the data can be complete and you put it in the model to predict it. Can you see it?
You mean this clean DF now?
Yes,
I'll
that's what you need to get to.
pass it on the model.
This clean DF was coming from without NaN. You are going to pre-process your with NaN now up to this stage.
Yes.
Put it in data in the model. That's all.
Really?
You don't need to select features or anything because this feature was used for model. Okay. Ezia, are you in the class?
I am very much in the class, sir.
So the pre-process, we follow the same pre-processing method that you have followed. That's how you do it too. The processing method followed, the processing method used up to the clean DF. Okay? So once you have that clean DF, you're okay. Then you just put it inside the model to predict. Let me run through it. Okay? Fast and furious. Fast and furious. All right. So already we can quickly do select. I'm just going to copy. Do you remember? I'm just going to be copying. You know, it's already there.
Yes.
So, Ezia, please, if you have any question, ask. So, hope we are not too. I'll copy this. It's the same thing. I'll copy this. Ezia, are you with us?
Yes. We'll do all those things
Again,
before.
yeah. You do it again. So if I copy this, it's same thing. Nothing is changing. So, no problem. I'll just do copy. Because anytime you are doing it, that's the standard. So I copy this. Can now change the name. So this will not be without NaN. This will be with NaN. Remember, are you seeing what I'm doing? And this one will be flow NaN.
Yes.
Okay.
Yes.
And don't forget, you can see something is still changed, just that because the data set is not the same thing. Okay. So that you don't go and replicate. Are you seeing what I'm doing?
Yes.
So don't say because I'm just copying. So I'm copying with what we should copy. So I think this should be fine. You see, I've gotten that right. Can you see?
Yes.
So after that, I've copied this one. Okay, we have gone past this stage. The next stage is let's use this method as I'm copying this. I've explained all this one so you know what to do. I've copied this, so I'm going to put it here again. So this one will be with NaN. Just change that so I don't have the same name. W will go. You see what I'm doing? This one will go because I need this. Are we following?
Yes.
Good. That we have that. You see? So after that, okay, this is copied. Target also. Are you seeing it? Because I have to remove this target. Don't forget that target is the NaN, which I don't even need. So you must remove it so that you can see it that I have removed. Target is the next. Target for flow. Because that if I do this now, I will have NaN. It should be NaN or true. Do you see? Do you see?
Yes.
So after that, I've copied this. Okay, the next thing is standardize, right? Standardize. I don't need to import anything. I've already got this scalar. I'll just copy this. This scalar is I'm using the same standard scalar. You should not change it. Don't standard scalar in the you're not going to use normal life. Anything you use is what you are going to use. we maintain the same pipeline, okay?
Yes.
Uh-huh.
Yes.
Eziaku, are you following? This is standard. Let me just put it here. Standardize, so that's standardizing. I just put this here. Then let me go and copy the feed transform straight on what pipeline. Feed transform straight. Copy. Feed transform. I put it here. So what will change is the data name will change. Are you seeing it? Num data nan. That's what we call it here. Okay.
Yes.
So num data nan. Don't forget to num data nan. Yes. So I can maintain this. If I do this now, it will transform it. Can you see? That's already gotten for the original data. Are you following?
Yes.
Feed transformed. After the feed transformed, please, if it's not clear, ask you. So we are done after this stage. The next thing
It's
is
clear.
we don't need this one. You remember, I just to show you. So the next thing is convert to data frame. You know you have to do this because you want to concatenate. Do you remember?
Yes.
Convert to data frame. So what are you passing? You're passing num data is still num data. Column is still columns, and I'm good. Okay, I can run this. Okay.
Yes.
Good. You see? So after that, then we move to categorical, right? So we have defined the
Yes.
one note already. So I only need this. Control C. I put it here. Control V. I recopy. Control C. I remove. And I take it back. Voila. So I've gotten what I know. Copy up to this level. So I have it up to this level. So what we change? W we move, right? One not cut
Yes.
WO. I think it's okay like this, okay? Because my cat at this point is still my, look at what we define as the cat. Okay, cat
Yes.
data nan, okay? I'm not hearing Eziaku.
She's
Yes,
eating.
All right.
She's eating.
Oh, okay. Okay. Please follow. So this is encoding the categorical. We've been able to encode the categorical. So already we are gone past this stage now, all right? So the next thing is reset. Don't forget the reset I told you. So just do the reset. Okay? Resets. We don't need targets. Do you agree?
I agree.
Because target is what we want to predict. So, and it's even none. So we don't need to even reset targets. Rather, you only reset categorical. Okay?
Yes.
All right. So resetting card data. Is it card data? Yes, we have reset. If you run this now, card data becomes this. Okay? You see 16051. Then I can now concatenate numerical, right? And categorical.
Yes. Yes.
Num data df. Num data df. Num data df. So 16, see that 16051, 16051. So that's good. So concatenating is the next thing. So we should now give you the data frame or the data frame. Concatenating, where's concatenation? This concatenation, right? I just call this
Yes.
Control C and I paste it here. But in this case, I will call it test set. I will not call it test. That's what I want to use, right? Test DF. Okay? Test DF.
Yes.
I will remove, I don't need target. Target should not be part of it.
Your first line is test you wrote instead of test.
Okay, thank you. So I will remove the targets. You agree because you should not be there.
Yes.
All right, good.
Yes.
So this is the data. So this is a clean data now that has taken the process we have followed. And I just need to put this one inside my model and I'll predict my Y. Okay? I'll predict that. Do you understand the step I've taken now?
Yes, I understand.
So at the end of the day, I have gotten to this. So you don't, this is where you end. All this feature was what when you're trying to build a model, and you're not building a model here. You're using an already built model now to make the prediction. So therefore, you just make the prediction. So predict the NaN of flood in the flood underscore NaN dataset using the built model, right? That you have built from the built model from the flood data without NaN, right? NaN datasets. I think if you read this, okay. So we just call the model. You call the model. Don't forget the model is logreg, right? So I can say test
Yes.
predict will be equal to the model is logreg underscore reg dot predict.
Oh, really?
Yep, we did the test df. Control C. Test predict. That's your value.
Wow.
Just like this, and we were flying coasts all around our this thing. That,
Imagine
hey,
in that
child.
one we did. Ah, God,
You
I
did well.
beg.
It's good. It's good. It's good. That's how you will learn it. Okay. I love that approach. Just make you to explore. So you just predicted it. So you need to now fix it. So let's move ahead. You understand the idea now.
Yes.
Yes.
So I have predicted this is the. You can see that this test, this one that we did is like the unknown data that I was telling you, and that's the essence of model. You build a model on existing data, which is trained data. You use an existing, not existing data that the model has not known, and you predict it. So it has predicted all the NaN value now. That was the target, because of course it's the target now, right? In the flood. Okay, and it has predicted it using the model that we built with something. So what I can now do here is, at this stage, I can convert this onto a data frame so I can see the way it is. So if I want to make it convert to data frame, so that I can see the way it is, convert to data frame. So what I'm going to have is, let's call it flood predict, so that it becomes clear. Flood predict, like you now know what it means, right? Is equals to pd.data frame, yeah, because I'm converting to data frame, yeah. Pd.data frame into what did I get? I've gotten the prediction, but this prediction is an array, and I want to convert it to, okay. I will just do, you can pass this and declare the column. No, you can do this and say test predict comma columns equals flood, right? And your test predict will appear in form of a data frame. Control C, Control V. You see? You see that?
Mm.
Yep. I can now go ahead and replace it. So I just convert to data frame, nothing. Just I just take away from this array so that you can see that it has predicted the whole 16,000
Oh, okay.
missing value. You know, yeah, it's just an array. You might not know, maybe it's that 16,000, but I've just shown you that the entire thing that you don't have, it has it now. 16,000 or no value is predicted. Okay,
Yes.
are we good?
Yes.
Yes.
All right. So let's quickly now the next thing is I can now put this thing together, because the essence is I should now replace the NaN with the value I've known now. No, that should be the right thing. Do you get it? So two things. This is data frame. I can concatenate this one now with this value, with this column original NaN. This is original NaN. This is original data, right? So if I remove this, if I drop this, and I concatenate this one with what I got, I'm fine. Do you know that I can do that, right?
Okay. Yes.
Because I don't need this rubbish guy again now. I've gotten a replacement.
Yes.
So is it that first of all say, okay, drop this column, and data set will become flown, whatever, then concatenate with the one that I've just gotten, that I've just converted. It will give you the data
Yes.
frame without NaN. Do you get the idea? That's one way.
Yes.
Do you get the idea?
Yes.
Yes, it's clear.
So you can do that. So let me go to teach another way. You can do that. So the next thing is we have to replace, because you need to get the new value now. Replace the NaN now, the NaN predicted now in the flood underscore NaN data, because you don't need it. I now need the original data since I've gotten what I was looking for. So don't forget that the flood is this is the original data that was giving us the problem. So you see, so I just want to remove this guy. I don't want it. So, but I've gotten the equivalent value, which is this array. So for me to replace, you can do that. First of all, say drop this. So if you drop this, you know it's going to remain from station to period. That's one data. You can put under name. Then you concatenate that one with this guy. You have achieved your result. Are you getting the idea?
Yes.
Yes.
So I can just say new flood. That's one way. New flood data without NaN. Let me just say new flood so that you know that the one with the original one also has its own case. This new flood data with NaN. Okay, let me use okay, let me try another concept. Flood NaN. The data set was the original. This original data set, and I say dot lock. Go into lock is I want to extract all column in the data set. What was the column I'm having? The column of interest is flood. That was the error. All the flood column. I said this is like grabbing in the data set of flood, grab the column, data set of flood NaN, grab the column of flood, which is correct. But not everything. Just pick the one that is having is NA. But that was the original intuition. Do you agree with me?
Yes.
Yes.
Whereby the value is NA, now that's the missing value, which is going to be NaN. Then replace it with, give it a name, let the name be maintained as the flood. I don't want to change it, but in this case, let it be equals to the prediction that I made. Voila. Where's the prediction? The original array. Control C, I paste it here. Control V. What you did here is nothing but, I'm saying that in the data that I have the problem, I am grabbing this one. This lock means that grab all the column of interest. Column of interest is flood. It says every value in the column of interest, which is none. You know, this SNA is going to be NaN, even if it's not NaN. So it's going to be interested in the one that is NaN. Then when you grab it, change it. Let it be equal to the prediction that we made. It will still work. Okay? Hello? Are you confused?
But this one you're
Yes,
doing is
yeah,
just
yeah.
another way, Abi.
Yes, another way. The
I
one
don't need this other way. I don't.
no, this isn't better because the one I told you, what if there was a disjoint in the data set? I've replaced it. Okay, flood has been, NaN has been changed to what I wanted. Okay,
Wow.
so I've changed. What we just did here is go to the data. Our data is flood now. Where the column, what's the column? Column of problem is the flood. Where is this NA? This is what the statement. Maintain the same name. This one is maintain the flood. Let it be called flood, and let it be equal to the predictions I made, which was the. So you're able to do this because I help you to convert to data frame. If you don't know how to convert it to data frame, and I show you that short one, I remove the flood, then concatenate it back and get a new data frame, you might not, it's going to be difficult for you to get it in. So there are I've taught you two different ways to do it now. So at your practice, you can follow that method, remove from this original data, remove this guy. That means you are dropping the entire of this column. Then to give you a new data frame without this none, right? So we cannot concatenate the obtain new data frame with the concatenated value. You get the idea, which will not give you the new data. But that might not work all the time. So that when you go and say none, again, don't say Larry did not tell us
This
this
one
one.
is very simple too. This one is very simple.
Why this one is important is if data is large and we didn't even do any separation. You know, if it is the original data set I'm using, the original one that we started with, this will still go ahead. The only thing it's going to be looking for is inside the column, inside the row that has none, and that's what going to replace. It will still maintain your 0, 1, and just go and put none and go and deal with none with original data, and I'll still get the same thing. But you know, I've taught you two different ways. So you have gotten a new data now that is not with the none again. You can see you've corrected the missing value. So I can now join the two of them together now so that I can have original data now that has no none. Do you understand the idea? We have one data that we said without none. That was what we started with. Then we've been able to manipulate the none and get a new data set. Are you getting me? Using our prediction method.
Yes.
So you're going to concatenate now so that you can now have original 20,000 data that you started with. Is it clear? Is it clear?
It's clear.
Now, Mag, is it clear?
It's clear.
So do not worry. If what you wanted is the one I told you, try it. Remove this one. The only thing you are doing 2 steps here. You will first of all remove this one, drop it completely. It will give you a new data frame, call it another name, then concatenate it with the data frame that you have gotten. It will going to be the same thing. So if that works for you, but this code is essential, and there's a particular problem or project that you're still going to do that you see the importance of this. But if, of course, the only thing is that you might need to do more cell, but you're still going to achieve the same results. Voila. So let's continue. So you now need to concatenate the whole data now, which will now give us what we are looking for. Are we good to go? Are we good to go?
Yes, yes.
So what you need to do is now consolidate. So then your assignment will start now. Consolidate all the data now, all the data sets to give the original data. Let me just, I don't know. It's just English. So to consolidate, voila. What I'm saying is, okay, what are the two values? What are the two data? We have data without none. Go and call that one because that's the original that you started with. You just need to process something. It's not like we are forgetting it. So our original data set, when we did this two splitting, we splitted them into two. So go back to that splitting where we made the splition. This is the one we started with when we do the splitting. We have this one. Don't forget. Yes, this is without none, right? Which was 4,000.
Yes.
Without none, this was the first one. I will not put it so that you can see everything. Without none, then I have with none. With none now, which is now this. Because I've been able to correct. Initially, when we did with none, there was none here, but it has been corrected now. So the original without now is now, it has helped me to get the one that has none initially. So this is now with none. So these are two complete data now. None of this is having missing value. You can check now. If you check without none, no missing value. If you check with the one that is none, there's no missing value again. Everything is clear.
Yes.
So I can now concatenate. You can ask, okay, full df will be pd dot concat, right? And I'm going to test your brain now. Concat, based on what I've explained, if you follow me, I will know. Flood data. Okay, let me do flood without none. I've explained this. I'm still going to ask you now. So be prepared. You don't know what I'm going to ask you, but I'm going to ask you something. Then the second data. It can be anywhere. Anyone can come first. Okay, what's going to be next? What am I going to put here now?
Ask this.
Axis what?
Equal 1.
Equal 1. Are we good?
Yes.
Then you are wrong. Axis should not be equal to 1. Axis is equal to what? It should be equal to 0. Are they
Okay.
not the same name?
Oh,
Yeah,
0,
the same
0.
column.
Yes, yes.
Oh, I got you. I said I was trying to prepare. I'm going to ask you. That's what I told you. This is the same name. I'm not creating more column. Rather, I just want to add it from the bottom. Just push it up. Okay? So it will be 0.
Yes.
I know I will get you. So full DF therefore should give me 20,000 rows. Exactly. I've joined. So this is a new clean data. If you do full DF none now, you know, go to everything will be clean. Dot is none. Dot sum. Is it clear?
Very clear.
Good. So this is your data. So this one now is now a clean data. So you can now begin to now build a new model. You know, if you've not built a model that we take care of unknown, what I mean that we this data now is now what we are going to build a model on. We build a model on this data set now that we can now use a test and unknown data now to predict and to predict it. Do you get it? Do you get it?
Yes.
Is it the way we
Yes.
build model inside the model? So the first one we built was just a model that will predict the NaN, which you have been able to overcame. Overcame the NaN, and the model was doing fine. 99% is not a small, so it's predicting it perfect. That's what it means. Do you get it now? It's a good prediction. So instead of me to have removed 16,000, so this 20,000 data set now is not the original data set that we started with. But now I've improved it, that I've been able to correct the NaN. So I have a complete data now. So this data set now is what we're going to be using now to build a new model. Not you're not going to, yes. We have not solved the
Hey.
problem. Have we solved the problem? What we did was to split the data. We have split data. We have viewed the model with the data, and we have detected the NaN. We have corrected it. So this is a new data set now. I don't know if you're getting. Where is the question? Look at the project now. I think. Load. Where's the question? Mark has touched this thing. See this man.
Hey, see me, oh.
We have touched this thing. I should see the Mag. This is not fair, nah. I want to load the question out.
Innocent me, oh. Hey.
Anyway, I want to get the notebook that PDF. Yeah, open now. Mark. Anyway, it's a pity. You cannot underestimate what Mark can. You have to be very careful with Mark these days, honestly. Just want to open so that I can show you what I wrote in it, and I can't find it.
Man is innocent too.
Eziaku. We finally won.
Sir?
Yeah, open, we won. So
Yes,
look at what we said. We have splitted the data. Number one is correct. We have trained a model with the data set that has no missing value. Remember, all necessary. This is completed. 3 says use the train model in step 2 to predict the missing value. We have done it. Can you see? Note that the data set, blah, 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 we have done that one. 4, you need to consolidate. Have we not done it?
Yes, we have.
You now said train a new model on the consolidated data set to predict the because our interest is to do the prediction of the NaN now. I mean of the flood. Is that not the original intention? So you have not built a model that will predict NaN, that will predict flood. You have not. You're just using between to get something. But the model you built was for NaN, not for flood. Am I correct or wrong? So we now use the original data set now, which is the consolidated one, to build a model that will now be able to predict the flood occurrence. So then
we should do that one assignment.
Yeah, that's an assignment. So that's what I asked you. You can see 1, 2, 3, 4, 5 step is done. So this one, just build a model. So you're going to use this data now up to this level. Then you now start your new pre-processing. What do you need to do? You check missing value. You check whether there is duplicate. You, of course, I know that there will not be missing, but there will not be duplicate again. So the only
The
thing is,
data is now very perfect now. No need
yes,
of doing all those
yes, it's
preprocessing
not perfect,
again.
but no, work with it. Do the step. Don't jump it. Write the code. It will give you 0. Yeah, okay. Don't skip it. Okay. Like imagine this is what I gave you. I don't know. You were able to know now that it's clean because you are with me. So when you do that step, you now go to, is it standard scalar you want to? You have to do the describe to know if it's good, if this one will be standard scalar, okay, or it's minimax, or it's normalization.
So
You have
you
to do.
mean that this one now, this full DF now, will separate it into norm and cat again?
Of course, you are doing the whole
Hey, okay,
process.
assuming we did not know
Assuming
that
you
it's
do not
already
know,
clean.
so you are going to follow the. Of course, even if you know, won't you do categorical and numerical selection before you build model? You do it now. I forgot.
No, I
So
don't forget.
you're going to do it. So this assignment will be use this data set as I'm talking. Let me rewrite it. You cannot your something cannot work for me again now. Assignment, which is the last part of the project, and you are done. And this is a beautiful work, honestly. So assignment, what you are going to do is use the full DF and build a model that can predict flood. Because that's the original. Because that was the original intention. Do you understand? So we have not built the model. So please note
Yes,
here, don't use logistic regression again. Why? Can anybody think of the reason why I should not use logistic regression?
because the model will cheat.
God bless you, clap for yourself. Because you have already used it. The model has already seen the data. So you can't use logistic regression again. It's just repetitive. He has learned it. They are super shitter. Okay? So don't think behind is another thing, except to take this data into a new notebook. Well, if it's on this notebook, he has learned it. He has nothing you are doing, just be laughing at you. He has learned. Do you get the idea? So use another algorithm. But I want you to use 5 algorithms. 5
5
different
different.
algorithms. Yeah. 5 different algorithms. Well, I said you should tune your parameters. 5 different algorithms. Use 5 different algorithms. Yeah. Use 5 different algorithms. So the only thing you need to do is just pre-process it. Check info, check shape, describe so that you can get the choice of either scalar, either minimax, or either normalization. In fact, for me, to make this assignment enough for you, do scalar on the numerical data, blah, blah, blah. Build your model, look at the score. Go again. Do that means you're going to do separately. Now, the same data, now try to use minimax, okay? With minimax, build the model. You understand me? Are you
Yes,
there?
on the same notebook or on
Yes, on
different
same notebook,
notebooks.
but use
Okay.
different model instead of different that 5 algorithm. Use one algorithm. No, I want you to check the difference. Okay, use one single algorithm on the same notebook. Do for scalar. See the score. Go again, another line. Use minimax. You get what I'm saying now? Again, the same
Yes.
process. Build the model. Use that same algorithm. Look at the score. Again, go to normalization. Do you understand me? Use that same algorithm. See the difference, and you get. Then do standard, scalar, minimax, and normalization at the same time. Use the same algorithm. Get the score. Don't do 5 again. Do you understand what I said? One single algorithm, but you are tuning it.
Okay.
You are changing the process
Okay.
of the processing, and see what you're going to have. Okay? Is it clear?
Okay. Yes.
So what you're going to do is use the different transformation, numerical transformation here. Numerical, no, our category is just still one not encoding. Now it's not changing. Here, because of just one thing. So one not encoding will remain one not encoding. Is that clear? So use different numerical data trans numerical data transfer.
On one algorithm.
Not algorithm, and check the impact in the score. Okay, so you have explained it. So that's what you're going to do. I've explained it. So use standard scalar, build your model. If you want to use random forest, if you want any, just pick one model. Okay, use standard scalar up to category of everything you have done. Build your model, do your score, make your prediction, then do your score. Look at the accuracy. Okay, then the same data, go again, impose minimax. You know, you're not going to repeat the step. You just the position at which you are doing the transform. That's the only thing that will be changed. Everything will be the same thing. You get it now. So you're not doing much work.
Yes.
You only need to do the work once. So you're just copying and changing. You get the idea. So you are still building the same model. But in this case now, use minimax. Again, go to normalization. Do the same thing. Then you see by yourself, you can write what you observe, comment out your observation, then do the three at the same time. Standard scalar, the output of standard scalar will go into the minimax. The output of minimax will go into the normalization. At the end of the day, put the model again and see. Okay.
Okay.
Then comment.
Please include this part where I said we should do the three at the same time, so I don't forget.
Comment on your observation. So this will be and use the three. And use the three numerical transformation. Hub transformations all together. Okay.
Yes.
Are we good?
Yes.
All right. That will be the end. Thank you. So, any question? Any question? So, if you encounter a project now that the data, that the missing value is much, you don't have any problem. So, I said you should optimize the algorithm. So, by the time you finish, I'm going to be going forward to see how to optimize. By the time you see. So, the little optimization you're going to be doing now is to check data imbalance, which you are still going to note to see the imbalance. But I won't show you that one until you finish your 3D model. So you comment and tell me what you observe, okay? So without much ado, any questions so far?
No question.
Of course, good. Okay, we see this as a way of optimizing. All right. Okay. So far so good. Here is where we are. So you're going to build this model. I've already seen that this model, despite the fact that your logistic regression was doing fine when you're using to predict it now, you get about 90 something percent. That might not be the case when you build this model with the whole data set, because I can see data imbalance. But don't worry, build the model. So another way to optimize, which is I've told you, model building, and you're already good. So how can you begin to optimize your whatever to make it sensible? Then will not be the next step. So what we're going to be doing next time is to do data balancing. I've already seen imbalance in data set, but don't worry. So when you build this model, you're going to be surprised. Your accuracy might be very low. Don't doubt it, okay? Because I've seen what can cause it, okay? Just build it on each of those things, but look at the observation. Is that clear? Is that clear? Is it clear?
Yes, it's clear.
All right, thank you. At this point, welcome to class. So I think we just want to start now, Abby. We've not started.
No, bye-bye.
Mag. All right. Eziaku, any question? Let me stop sharing.
No, sir, no.
All right. So I can stop recording at the same time. Voila. So